Let's travel back 300 million years to an era so distant that Earth itself would seem an alien, unrecognizable planet. Back then, the continents we know today didn't exist. In their place, there was a single, colossal landmass, united into a single whole. Its name is Pangea. This supercontinent was more than just a geological oddity. Imagine a world of unprecedented contrasts. Endless, sun-baked deserts stretched at its very heart, while dense, wild forests, teeming with prehistoric life, stretched along its coasts. To understand what titanic forces were able to first assemble this puzzle of continents and then mercilessly tear it apart, we must peer into the very heart of our planet. The idea that the continents don't stand still, but rather drift across the face of the Earth, was first proposed in the early 20th century by a scientist named Alfred Wegener. He proposed that all the continents were once a single entity, but over time, some powerful force pulled them apart. This force turned out to be the slow but inexorable movement of tectonic plates. Imagine the Earth's crust not as a monolithic sphere, but as a mosaic assembled from gigantic pieces. These plates, like gigantic rafts, float on the surface of the viscous hot mantle. Over millions of years, they move, collide, and separate, driven by invisible currents deep within the planet. At the end of the Paleozoic era, about 300 million years ago, this geological ballet reached its climax. The process of separation itself began approximately 200 million years ago during the Mesozoic era, and it was not peaceful. Pangea split into two smaller supercontinents, Laurasia in the northern hemisphere and Gondwana in the southern hemisphere. This planetary separation was accompanied by powerful earthquakes that shook the Earth to its very foundations, violent volcanic eruptions, and the birth of new oceans. The process of land separation began with what's known as rifting, a moment when the continental crust began to stretch and crack like ice. These giant cracks in the Earth's crust allowed magma to escape to the surface, creating new land forms. As the cracks widened, they filled with water, and thus, in the early stages, the Atlantic Ocean began to form. Over the following millions of years, the continents drifted further and further apart, settling into the positions we see today. But even after the initial separation, tectonic movements did not cease. They continued to shape our planet, and the continents still drift at a rate of several centimeters per year, driven by underwater geological activity. Our planet is in perpetual motion, and this motion not only opens our eyes to the Earth's changing nature, but also allows us to glimpse its complex geological history, which created the world we live in. More than 200 million years ago, a gigantic landmass known as Pangea dominated Earth. The discovery of absolutely identical fossils of ancient plants and animals on continents separated today by thousands of kilometers of ocean dramatically expands our understanding of that era. This clearly indicates that these lands were once located adjacent to one another. A striking example is the remains of Mesosaurus, a small freshwater reptile. Its fossils are found in both South America and Africa. This fact irrefutably proves that these two giant continents were once part of a single landmass. This remarkable connection between ancient life forms is the clearest evidence of how the continents slowly but inexorably drifted apart over millions of years. In recent decades, technology has advanced significantly, giving us new tools for studying these ancient formations. Geologists are now armed with powerful computer modeling and geophysical methods. They can digitally reconstruct the movements of continents in the past and understand the colossal forces that shaped our planet. This modern approach allows us to peer into Earth's geological history more deeply than ever before. It helps us appreciate not only the grandeur of Pangea, but also the incredibly complex and dramatic evolutionary process our planet has undergone. The variable landscape of the supercontinent Pangea, which existed approximately 300 million years ago, is a true mystery for paleoclimatologists. Pangea was a single landmass encompassing almost all of Earth's landmass, and this alone had a colossal impact on the global climate. While we might mistakenly assume that a single weather system reigned over such a vast territory, Pangea actually exhibited a stunning diversity of climatic zones. Its incredible size and geographic features created vastly different conditions. Pangea's climate was strikingly different from what we're accustomed to, especially in the interior of this supercontinent. Away from the moderating influence of the ocean, days were unbearably hot and nights were piercingly cold, leading to monstrous temperature swings. These conditions were precisely what gave rise to the vast deserts. Here, the wind was the primary sculptor, shaping the landscape over centuries, creating lifeless sandy plains and bizarre rock formations in this arid heart of the world. The landscape changed dramatically near the coast. Coastal areas were a completely different world. Moisture evaporating from the oceans created a wetter and milder climate. On the western fringes of Pangea, the weather was much more moderate. These regions received significantly more precipitation, giving rise to lush, dense forests and supporting the flourishing of diverse ecosystems in the supercontinent south. This, in turn, influenced the climate as a whole. Furthermore, the position of the poles also influenced the weather. In certain eras, this led to the advance of glaciers and the formation of massive ice caps. This fact tells us that even on a single supercontinent, zones of extreme heat and freezing cold could coexist. The evolution of life during the Pangea era was inextricably linked to these climatic swings. We see how living organisms adapted to their environment, how the diversity of plant and animal life emerged, which would later shape the ecosystems of the entire planet. The dramatic transition from a single supercontinent to the separate continents we know today changed not only the Earth's geology, but its very nature, and climate played a decisive role in this, becoming the forge of the biological diversity we admire. 300 million years ago, Earth was dominated by a gigantic landmass we call Pangea. This supercontinent exerted a direct and powerful influence on climate and weather patterns across the entire planet. Pangea was so vast that its size directly influenced ocean currents and the movement of air masses. Because of this colossal barrier, vast areas of the continent's interior were virtually cut off from the influence of the ocean, the primary driving force shaping weather and climate. Because Pangea's interior was thousands of kilometers from the nearest coast, summer months saw extreme temperatures, with the air scorching hot. Meanwhile, in winter, these same lands could be gripped by severe frosts. The lack of nearby ocean waters to smooth out these extremes led to such sharp fluctuations. These temperature swings created a much harsher continental climate than today's more balanced world. It was this very feature that led to the formation of a wide variety of ecosystems, from parched deserts to humid, dense forests, depending on the specific region. Moreover, Pangea's very presence on the planet influenced global wind patterns. The landmass's position completely altered the distribution of solar heat, which in turn altered wind directions. Because weather systems over this supercontinent evolved in unique ways, its different regions experienced unique natural phenomena. For example, some areas might suffer from torrential rains, while others slowly turned into arid wastelands. This created completely different habitats and pushed the flora and fauna of the time down different evolutionary paths. Ultimately, Pangea's incredible size and unique shape altered the planet's climate dynamics so dramatically that we still feel its echoes today. Studying these ancient weather patterns provides us with invaluable information about how climate changed and the colossal influence of these gigantic land masses. Ancient weather systems remind us of the close and inextricable connection between the geology and climate of our planet. The supercontinent Pangea, which existed approximately 300 million years ago, caused dramatic climate changes across a vast territory encompassing almost all of Earth's landmass. As a single entity, Pangea gave rise to an incredible diversity of natural zones, profoundly influenced by its unique geographic features. The interior of Pangea, cut off from the ocean's gentle breeze, faced truly extreme conditions. Insufferably hot summers, icy winters, and endless arid deserts created a stark and harsh contrast. Meanwhile, the coastal regions of Pangea teemed with a completely different life. A more moderate climate prevailed here, and the shores themselves were surrounded by warm, shallow seas. This fostered the development of dynamic ecosystems rich in marine life. The coastline enjoyed mild weather, which supported dense forests and abundant vegetation. It was a world where harsh natural conditions coexisted with an incredible wealth of flora and fauna. The contrast between the inland climate and the lush coastal ecosystems played a key role in shaping the plant and animal species that later spread across all the continents. Pangea's geography also powerfully influenced global wind systems and ocean currents, which in turn shaped the climate. When the continents merged into a single giant land mass, it completely altered the distribution of heat across the planet. In many regions, seasonal weather changes became much more pronounced, leading to vast differences between seasons. Eventually, as Pangea began to break apart, these climate zones began to separate. These differences continued to grow, influencing the evolution of life on Earth. A new era of transformation had begun. It was during Pangea that the foundations of many of the ecosystems we see today were laid. This clearly demonstrates how tectonic shifts in the distant past had long-term effects on climate and biodiversity. Ancient environmental conditions continue to influence modern global climate patterns. During the era of Pangea, the supercontinent that existed approximately 300 million years ago, the arrangement of land and sea played a crucial role in shaping the global climate. The unification of all the continents into a single massive landmass effectively blocked the circulation of ocean currents, the very currents that play a key role in regulating temperature and weather across the planet. These stagnant ocean currents simply couldn't move as efficiently as they do today. This led to sharp, dramatic temperature fluctuations across different regions of Pangea. The landmass of this supercontinent stretched from the equator to the polar regions, creating a world of climatic extremes. Its interior likely suffered from intense heat and drought, while coastal zones enjoyed more moderate temperatures. The ocean, even with its diminished influence, created both vast deserts and subtropical zones with lush vegetation. These striking differences reveal the full spectrum of natural conditions that were strongly influenced by limited ocean circulation. Moreover, the disruption of ocean currents during Pangea's existence also had a profound impact on the entire planet. Imagine the entire planet's circulatory system, its oceans, practically grinding to a halt. This is precisely what happened when all land masses were consolidated into a single supercontinent. Global water circulation was disrupted, radically altering the distribution of nutrients in the world's oceans. Living, moving oceans can lift vital elements from the dark depths to the sunlit surface, nourishing marine life. But during the Pangean era, vast masses of water became stagnant, almost lifeless spaces. This stagnation stifled biological activity, hindering the evolution of marine organisms and entire ecosystems. The consequences were felt everywhere. Food chains collapsed, affecting not only marine life, but also life on land dependent on the ocean. But then, about 200 million years ago, titanic forces began to tear Pangea apart. It was a moment of liberation. The oceans began to move again, their currents restored, setting in motion the formation of a more complex and interconnected global climate system. The continents set out on their great journey. This process led to a much more efficient mixing of ocean waters. Like a giant mixer, currents began to redistribute heat and cold, stabilizing temperatures across the planet and creating incomparably more favorable conditions for life to thrive. The transition from a single monolith of land to the familiar necklace of continents we know today laid the foundation for the very climate we observe today. This grand geological drama underscores how deeply the fate of life on Earth depends on the great ocean currents. Let's travel back 300 million years to the heart of Pangea. We find ourselves in a unique environment that largely shaped the evolution of life on our planet. The air here was completely different, dense, saturated with carbon dioxide, but at the same time, it was incredibly rich in oxygen, creating ideal conditions for lush plant growth. It was the fuel that sustained life on an unprecedented scale. A stunning diversity of animal life flourished in this oxygen-rich atmosphere. It was here, in the vast interior of Pangea, that the foundations for many future ecosystems were laid. However, life far from the coast was a true challenge. These regions, cut off from the moderating influence of the ocean, suffered from extreme temperature fluctuations. These extreme fluctuations, from scorching heat during the day to freezing cold at night, became a powerful driver of evolution. To survive, organisms had to develop unique adaptations. Plants and animals developed incredible strategies that allowed them to cope with both severe drought and the freezing temperatures of high-altitude plateaus. This adaptability played a decisive role in shaping the astonishing diversity of landscapes and ecosystems that emerged during this era. Pangea's location near the equator ensured a warm climate, but with a highly uneven distribution of moisture. Seasonal monsoon rains transformed entire regions into gigantic swamps and impenetrable forests. The biodiversity here, especially in the southern and equatorial parts of the continent, was simply fantastic. These conditions created unique ecosystems where both giant herbivores and the predators that preyed on them thrived. It was a highly complex life support system that spanned the entire continent. But nothing lasts forever. Tectonic activity, the very force that once stitched this world together, was now preparing to tear it apart. The inevitable breakup of Pangea led to catastrophic changes in both the atmosphere and land. As they split apart, vast land masses slowly but inexorably shifted in different directions, creating entirely new climate zones and previously unseen habitats. This profound transformation didn't just alter the planet's geography, it paved the way for new evolutionary pathways that life would follow after the demise of Pangea. Even today, its legacy can be seen in the biodiversity and ecosystems that exist on Earth. The climate shifts caused by this great continental drift catalyzed the evolution of thousands of new plant and animal species, ultimately shaping modern biodiversity. Moreover, the shifting continents had a colossal impact on the world's oceans. As the landmass changed, so did the paths of ocean currents. Yet these currents play a key role in distributing heat across the planet, determining climate for millennia to come. For example, the birth of the Atlantic and Indian Oceans completely reshaped the routes of warm water currents, forever altering the climate on adjacent continents. The breakup of Pangea had long-lasting fundamental consequences that we feel to this day. Rainy seasons changed, and the very stability of the climate changed. The story of Pangea is more than just a dry tale of tectonic plate movements. It is an epic narrative of how blind geological processes shape the climate and environment in which we live. This fascinating chapter in Earth's history opens our eyes to the intimate connection between climate and volcanic activity. The supercontinent Pangea, which existed approximately 300 million years ago, was a world of fire. During that era, volcanic activity played a decisive role in shaping the environment. For millions of years, monstrous volcanic eruptions were not rare events, but the harsh norm. This supercontinent was home to virtually all the planet's landmasses. The continents fused into a single conglomerate. However, history didn't stop there. Geological shifts began, setting the stage for their final and irrevocable separation. The first landmasses to break away from Pangea were those that would later become North America and Eurasia, as well as regions we now call Greenland, northern Canada, and parts of what would become Europe. This process began at the end of the Triassic period, approximately 200 million years ago. It was then that tectonic plates began to move, gradually leading to the formation of giant rifts, cracks in the Earth's crust. As a result of this process, oceans, such as the young Atlantic, began to emerge and expand between the newly formed landmasses. After this initial split, plate movement continued. South America began to slowly but surely drift away from Africa. This period, known as the Jurassic, marked the next phase of Pangea's breakup. The ancient supercontinent slowly disintegrated into the modern continents. This process, known as continental drift, led to dramatic changes in the geography, ecosystems, and climate of our planet. Over millions of years, each continent acquired its own unique, distinctive characteristics. Although the movement of the continent seems incredibly slow today, it continues. Tectonic plates continue to move, shaping the Earth's surface. These cataclysms released unimaginable quantities of gases and ash into the atmosphere, which had a direct and often fatal impact on the climate and ecosystems. One of the most terrifying consequences of this volcanic orgy was the release of sulfur dioxide and carbon dioxide. Rising into the sky, columns of ash and aerosols could plunge the world into darkness for years, blocking out sunlight. This phenomenon is known as a volcanic winter. Temperatures on the planet plummeted, creating unbearable conditions for life. But this fiery breath of the planet had another side. Huge amounts of carbon dioxide, on the contrary, could contribute to global warming, creating a greenhouse effect. The climate became wildly unstable, swinging from ice ages to tropical heat waves. Such abrupt changes made it impossible for many animal and plant species to thrive, disrupting the structure of ecosystems and even leading to mass extinctions. The very face of Pangea was constantly changing under the onslaught of volcanoes. Eruptions, molten lava flows, multi-meter-thick layers of ash, and the emergence of new land masses all contributed to the continuous reshaping of the continent's topography. This process could create new mineral-rich habitats that provided a chance for diverse organisms to thrive. However, more often, it meant that entire regions became parched and inhospitable deserts, and existing ecosystems were simply wiped off the face of the earth. The volcanic activity of the Pangea era had a profound impact on the environment, altering the climate and reshaping the landscape. These eruptions not only decided the fate of countless species, but also played a vital role in the geological and biological evolution of our planet. The legacy of that fiery era can still be seen today in the bizarre geological formations and ecological patterns on every continent. During the time of Pangea, approximately 300 million years ago, Earth was unrecognizable. This supercontinent united almost all of the planet's landmass, creating colossal interior spaces thousands of kilometers from the moderating influence of the oceans. This combination of climatic factors, geological processes, and the continent's enormous size resulted in the formation of some of the largest deserts in Earth's history. The landscape of Pangea experienced extreme climatic fluctuations over millions of years. The interior of the supercontinent was a haven of extreme temperatures, with scorching heat capable of melting rock during the day and piercing frost at night. Lacking large bodies of water nearby to humidify the air and moderate temperatures, these interior regions became arid, desolate lands. Over time, the lack of rainfall led to the emergence of vast, scorched territories on the planet, consisting of endless sandy plains and rocky plateaus. However, it would be a mistake to consider these deserts, known as the Pangea deserts, completely lifeless. No, they were unique ecosystems where life, adapted to unbearable conditions, waged a desperate but successful struggle for survival. Fossils found in these regions indicate the presence of hardy vegetation adapted to drought. Ancient reptiles and countless invertebrates thrived in these harsh environments, demonstrating an astonishing will to survive. Pangea's landscapes included shifting sand dunes as tall as multi-story buildings and deep, wind-carved canyons. It was a world both harsh and, in its own way, beautiful. But about 175 million years ago, when Pangea began to break apart, the fate of these deserts changed. The climate changed. Despite this, geological traces of those ancient deserts can still be seen in rock formations and fossil deposits around the world. Today's science allows us to travel back to that distant past, when vast land masses were gathered into a single supercontinent. 300 million years ago, this gigantic, interconnected tract of land had a colossal impact on the development of our planet. The climate and biodiversity of that era were truly unique. Pangea's location near the equator ensured a warm climate across its vast expanses. This fostered a thriving ecosystem. Lush forests covered vast territories, brimming with a diverse array of flora and fauna. Numerous species thrived, adapting to a wide range of conditions, from arid deserts to tropical rainforests. However, over time, the climate began to change dramatically and irreversibly. The geological forces that once held Pangea together did not disappear. They continued to operate. Tectonic activity, which led to the slow disintegration of the supercontinent, not only altered the contours of the continents, but also fundamentally affected weather patterns across the planet. As parts of Pangea drifted, some regions became increasingly arid, turning into deserts, while others, conversely, experienced a sharp increase in precipitation. These climate shifts created new ecological niches, allowing some species to thrive while others were pushed to the brink of extinction. This dynamic, constantly changing environment triggered significant evolutionary changes. Those that adapted to the new conditions enjoyed a future, while others faced the threat of extinction. Climate change also led to habitat fragmentation. The separation of once united territories contributed to the isolation of populations, which over time led to the development of unique, highly specialized adaptations. This process of isolation became one of the most powerful drivers of evolution. This tectonic shift became a powerful driver of speciation as entirely new species began to emerge from common ancestors. Fast forward 180 million years into the past. A monumental scene unfolds before us. The single supercontinent Pangea is beginning to crack at the seams. Under the pressure of colossal geological forces, the once monolithic landmass is breaking apart. These processes only gained momentum over time as the future continents, like giant ships, began their slow drift in different directions. And this event became the catalyst for a veritable explosion of biodiversity. Some species, finding themselves on vast drifting islands, were able to spread across incredible territories. Others, on the contrary, found themselves completely isolated, trapped on their continental fragments. Cut off from the rest of the world, they followed their own unique evolutionary path, sometimes developing bizarre traits perfectly adapted to their new isolated habitat. The legacy of Pangea is more than just a story of continental drift. It is a powerful reminder of how closely geography, climate, and evolution are intertwined. It is this interconnectedness that has shaped the incredible and rich tapestry of life we see on our planet today. Approximately 200 million years ago, the unified world of Pangea began to disintegrate, a process that forever changed the face of the planet. This monumental rift radically reshaped the world map, altering the balance of land and oceans. And this had a long-term, fundamental impact on climate systems across the entire Earth. Weather patterns, the direction of giant ocean currents, the developmental paths of entire ecosystems, all were subject to the consequences of Pangea's breakup. And remarkably, we feel the echoes of those ancient events in our climate even today. One of the key consequences was the current arrangement of the continents and their interaction with the global climate machine. Imagine, when Pangea broke apart, the vast Atlantic Ocean began to form in its place. Its emergence completely altered the circulation of water in the world's oceans. And these changes, in turn, play a key role in heat distribution and weather patterns around the world. Consider the Gulf Stream, a giant, warm ocean river that warms the east coast of North America and Western Europe. It's a living example of how geography, laid down millions of years ago, still shapes our climate. Mountain ranges, which were uplifted during the time of Pangea, also play a huge role. For example, the Himalayas aren't just the highest mountains in the world, they've become an impenetrable barrier to air masses, directly influencing the formation of the Asian monsoons. These mountain ranges literally dictate where heavy rainfall occurs and where, in their shadow, arid and semi-desert zones form where moisture simply can't reach. These geographic features are a vivid reminder of how Earth's deep history continues to be reflected in modern climates. Echoes of that ancient era, such as tropical rainforests and lifeless deserts, serve as evidence of past climates. By studying geological and climatic changes, the fossil record tells a remarkable story. It reveals how some regions, once thriving and vibrant, eventually became sun-baked wastelands. Studying these patterns, which evolved over millions of years, not only reveals secrets of Earth's climatic history, but also provides clues to predicting future changes in our ever-changing world. During the time of Pangea, which existed approximately 300 million years ago, the planet's climate processes operated at a completely different, leisurely pace. This supercontinent was a true paradise for the plant world. The climate across its vast expanses was incredibly diverse, from the sweltering, humid tropical jungles at the equator to the harsh, arid deserts inland. This diversity was the key factor, creating ideal conditions for countless species to thrive. In that distant era, when life could thrive in the warm and humid equatorial regions, giant tree-like plants known as tuberous mosses reigned supreme on the planet. These impressive creatures, resembling giant ferns, towered up to 30 meters into the sky, comparable to a modern 10-story building. Here, in this prehistoric garden, the first seed plants, similar in appearance to palm trees, also flourished. They possessed a remarkable ability to adapt to the changing conditions of Pangea, but in the cooler, drier regions, conifers dominated, the ancestors of modern pines and giant sequoias. These evergreen trees with needle-like leaves were perfectly adapted to the lack of moisture. Their presence not only enriched the continent's ecosystems, but also spurred the evolution of numerous new plant species. Carbon dioxide levels were significantly higher than today, leading to a powerful greenhouse effect. This, combined with the almost complete absence of polar ice caps, contributed to overall global warming. During this period, vast swamps were actively forming across the planet, where tons of dead plant matter decomposed for centuries without oxygen. These swamps played a key role in the creation of the fossil fuel reserves, coal, on which humanity relies today. Pangea's unique ecosystem, central to the carbon cycle, had a profound impact on shaping our planet's climate. As the continents drifted apart to occupy their present-day locations, flora evolved to adapt to the new conditions. Modern forests represent a complex balance of angiosperms and gymnosperms adapted to a wide range of climates. The differences between the ancient flora of Pangea and the modern plant world vividly demonstrate how dynamic our planet has evolved. This is clear evidence of the complex interplay between geological cataclysms and biological evolution over hundreds of millions of years. During the Pangea era, approximately 300 million years ago, the world was teeming with amazing creatures. This vast supercontinent became a cradle for unique species that thrived in its diverse ecosystems. Land animals were dominated by ancient amphibians and reptiles, as well as the earliest ancestors of mammals. Particularly notable were the giant amphibians of the late Paleozoic, which thrived in Pangea's lush, plant-rich environment. These creatures were much larger than their modern descendants. Some resembled giant salamanders and frogs, reaching the size of crocodiles. Their prosperity was made possible by abundant food, numerous freshwater bodies, and a warm climate. It was during this period that an incredible diversity of animal shapes and sizes appeared on Earth, some of which reached truly impressive proportions. The first reptiles also emerged at this time, particularly the early archosaurs, the ancestors of not only dinosaurs, but also modern birds. These reptiles proved perfectly adapted to the arid interior regions of the continent, which were developing as the climate changed. This was a major evolutionary breakthrough. The animal world of that period was marked by the emergence of numerous species that would later give rise to the formidable dinosaurs destined to dominate the planet millions of years later. The era of Pangea became a crucial chapter in the book of evolution. Giant amphibians and ferocious early reptiles laid the foundation for future biodiversity. Their emergence on the global stage marked the beginning of sweeping changes that ultimately led to the astonishingly diverse world we see today. The legacy of these ancient species lives on and influences our world. This process, though imperceptible to the human eye, highlights the dynamic nature of our planet and its constantly changing appearance. Understanding these early stages of separation provides us with clues not only to the history of the Earth, but also to the evolutionary history of the life that flourished on these lands separated for millions of years. The breakup of Pangea was a truly monumental event in the history of our planet. The geological saga of the formation of the continents we know today began about 300 million years ago, when the massive supercontinent Pangea began to coalesce. This giant united all the continents at the end of the Paleozoic era. However, Pangea's story doesn't end there. Perhaps even more fascinating is how long it took for this colossal structure to disintegrate. The breakup of Pangea began approximately 180 million years ago, at the beginning of the Mesozoic era. Over the course of many millions of years, tectonic forces began to tear apart the once unified landmass. This breakup was not an instantaneous event. It occurred in several stages, involving complex plate movements. Approximately 150 million years ago, the first major rift began between the northern continent of Laurasia and the southern continent of Gondwana. Each stage of this process lasted tens of millions of years, resulting in a gradual, inexorable drift of the continents. The separation of these vast land masses continues to this day, albeit at a very slow pace. About 300 million years ago, a monumental event occurred on Earth: the formation of the supercontinent Pangea, uniting disparate land masses previously separated by vast oceans. This merging of continents created entirely new habitats and dramatically altered climates across the globe, making the landscape more uniform. As a result, various species began to adapt to the new conditions, pushing them along different evolutionary paths. One of the most significant consequences of the formation of Pangea was that land animals, which had previously evolved in complete isolation for millions of years, suddenly found themselves face to face. They were forced to share the same habitat with other organisms, creating incredible competition and entirely new conditions for natural selection. In this world, where every day was a struggle for survival, the intensification of competition became a powerful catalyst for evolution. Imagine this relentless arms race. Giant herbivorous lizards were forced to adapt to new, tougher plant species that appeared everywhere, and predators followed relentlessly in their wake, honing their deadly skills and influencing every detail of their prey's behavior, from defense strategies to grazing choices. But then, about 180 million years ago, something momentous began. The great continent of Pangea began to crack at the seams. Slowly but inexorably, it began to disintegrate, a process that forever changed the face of the planet. In place of monotonous plains, forbidding mountain ranges, lifeless deserts, and endless coastlines emerged. This tectonic rift became a powerful driver of evolution. Groups of animals that once lived side by side found themselves forever separated by newborn oceans. In this isolation, they took completely different paths of development, adapting to the unique conditions of their new homes. The result was a veritable explosion of biodiversity, traces of which we find today in the fossil record. The legacy of Pangea is etched in stone, in the way the remains of ancient creatures are distributed across the globe, telling us the story of their great dispersal. Let's travel back 300 million years to an era when all the land on the planet was one. It was here, in the vastness of the supercontinent Pangea, that dinosaurs originated and began their rise to dominance. At that time, the world was relatively homogeneous, but as soon as the giant continent began to fragment, everything changed. The descendants of the ancient dinosaurs faced new challenges and new opportunities, which led to the incredible diversity of life we know today. The story of Pangea is more than just a geological chronicle of plate movement. It is a key chapter in the great book of evolution. The name Pangea means whole earth, and this world was incredibly diverse. The gigantic continent contained sun-baked deserts, dense, humid forests and vast inland seas reminiscent of today's Great Lakes, only on a much larger scale. Each of these zones was home to its own unique flora and fauna. At the very heart of Pangea, in its warm and humid regions, lay colossal forests. Just imagine the landscape. Instead of the trees we're accustomed to, giant tuberous mosses the size of houses and seed ferns towered here, creating a dense, almost impenetrable, green canopy. This prehistoric jungle was a veritable hive of life. A wide variety of organisms flourished here, from early, still clumsy reptiles and nimble amphibians to myriad insects. It was in these forests that the foundation for future evolutionary breakthroughs was laid. The diversity of species living here ultimately gave rise to many animal groups, including our distant ancestors, the first mammals. But once we moved away from these green oases, endless sun-baked deserts stretched out before us. These arid lands were a world of extremes. Severe temperature fluctuations reigned, and water was the most precious commodity. And yet even in such harsh conditions, life found a way to survive and thrive. Resilient and hardy creatures adapted to this hell. Among them were dinosaurs and other reptiles that evolved to tolerate extreme drought. The constant climate change on Pangea became the crucible in which a stunning diversity of species was forged, laying the foundation for all future life on the planet. While this epic drama of adaptation unfolded on land, a completely different picture emerges at the edges of this gigantic continent. The coastal zones and seas surrounding Pangea were yet another rich ecosystem. These warm waters teemed with life. They were home to amphibious reptiles, still undecided about their home, land or sea, and giant fish patrolling the shallows. It was then that the first coral reefs began to form, creating complex underwater cities for countless marine creatures. These contrasting worlds, land and sea, did not exist separately. They constantly influenced each other, creating the incredible biodiversity that was only made possible by the impending breakup of the supercontinent. The legacy of these ancient ecosystems continues to help us understand how resilient and inventive life can be. Life on Pangea, which existed approximately 300 million years ago, was a true test of endurance. The geography of those times was radically different from our own. Animals encountered a wide range of climates, from lush tropical forests to arid deserts. In this constantly changing environment, they developed unique survival mechanisms that allowed them to conquer the ancient world. In wetter climates, in dense thickets, many species developed the characteristics of true forest dwellers. Imagine powerful, tenacious paws that allowed them to climb the trunks of giant ferns, and extremely acute hearing and vision that helped them find food and spot danger early. These qualities were key to success in resource-rich areas, but in arid regions, a completely different battle raged, a battle for every drop of water. Here, animals developed incredible resilience to high temperatures. Their massive bodies helped them cope with the heat, and their special, nearly impenetrable skin protected them from fatal dehydration. These adaptations became crucial for survival in places where water was a rare treasure. Some species went even further. They began to develop unique traits that made them versatile soldiers, capable of surviving on both land and water. As a result, the world became filled with a remarkable diversity of reptiles, early mammals and amphibians. Spreading across the vast continent, they continued to adapt to local conditions, occupying ever new ecological niches. The dynamic environment of Pangea paved the way for evolutionary innovations that shaped the animal world for millions of years to come. Many of these ancient adaptations laid the foundation for the emergence of species that would later populate the fractured continents. Each such adaptation is a testament to the incredible resilience of life and its complex relationship with its environment. In this world, full of both opportunity and deadly danger, they reigned supreme. The fearsome predators of Pangea, this vast continent, home to a wide variety of ecosystems, became the perfect arena for their dominance. Archosaurs, a group that included the distant ancestors of modern crocodiles and even birds, became true masters of the prehistoric landscape. These creatures thrived everywhere, from dense forests to arid plains, and were among the most iconic inhabitants of Pangea. However, the most famous and fearsome hunters of that era were the early theropod dinosaurs. These bipedal killing machines, armed with razor-sharp teeth, paved the way for the dinosaurs' eventual dominance. As the Triassic period gave way to the Jurassic, new, even more powerful predators emerged. Among them were the ancestors of modern alligators and new species of dinosaurs. Large carnivorous lizards like Coelophysis appeared. Imagine a pack of these agile predators, like a pack of wolves, using their speed and coordination to hunt down and kill prey much larger than themselves. They were a demonstration of the astonishing efficiency of evolution. But Pangea wasn't just home to predatory reptiles. It was also home to giant amphibians called labyrinthodonts. These creatures, lurking in the murky waters, possessed monstrous jaws and hunted smaller animals, putting additional pressure on herbivores. The entire food web of that era was a complex mechanism where the survival of each depended on the others. This eternal struggle between predator and prey became the captivating backdrop against which the history of life on our planet unfolded. But the history of life on Pangea is not only a tale of prosperity, it is also a chronicle of great catastrophes. For millions of years, the planet was rocked by monstrous volcanic eruptions. The climate swung from hot to cold, and sea levels fluctuated unpredictably. Each of these cataclysms led to colossal shifts in ecosystems and left a deep scar on the tree of life. Among the most terrifying of these events were mass extinctions, such as the Triassic-Jurassic. But even earlier, there was the so-called Great Dying, which occurred approximately 260 million years ago. It was a true biological catastrophe, an apocalypse on a planetary scale. As a result of this cataclysm, up to 90% of all sea and ocean life was wiped from the face of the Earth. On land, things were no better. Up to 75% of all species disappeared. Imagine this desolate world. The biological landscape of Pangea has changed beyond recognition. Species that had thrived for millions of years have vanished forever, leaving gaping holes in ecosystems. The world stood in desolation. But it was in these ruins, in this desolate world, that a new round of evolution began. As Pangea began to disintegrate, the surviving species were given a unique opportunity. In the ensuing Jurassic, these changes laid the foundation for a new wave of evolutionary innovation. Yes, ancient ecosystems were razed to the ground, But it was precisely this desolation that gave new life forms an opportunity to emerge. Mammals, dinosaurs, and birds all had their chance, beginning to exploit the vacant resources and niches left behind by the extinct giants. It was a true explosion of evolution, an era when nature, like a brilliant sculptor, experimented with life forms, giving birth to creatures that stunned the imagination. Each new branch on the tree of life was bolder and more bizarre than the last. It was this burst of speciation that laid the foundation for the complex ecosystems of the future and ultimately led to the incredible kaleidoscope of living creatures that we see on our planet today. But life's path has never been smooth. Its great history has had its dark pages, global extinctions. And it's important to understand, these events weren't simply tragedies and losses. No, they became fateful turning points in the Earth's record, cruel but necessary catalysts for evolution. The consequences of these cataclysms rippled across Pangea, forever changing the rules of the game. And paradoxically, after each such catastrophe, biodiversity ultimately only increased, paving the way for the complex web of life that envelops the Earth today. Despite total destruction, life demonstrated remarkable resilience. It found a way to adapt, survive, and flourish again. And the best proof of this is the rock record left to us by the Pangea era. Let's fast forward 300 million years into the past. Pangea stretches before us, a single, colossal supercontinent, opening a window onto a world where all the continents were fused together. By analyzing the fossilized remains of that era, paleontologists, like detectives of the past, are reconstructing a picture of ancient ecosystems. And this picture is astonishing in its diversity and the interconnectedness of all life. Imagine the scientists' surprise when they find fossils of the same prehistoric fern or small reptile on the coasts of South America and thousands of kilometers across the ocean in Africa. This couldn't be a coincidence. It was an undeniable clue that these lands were once connected, part of a single, gigantic, continental puzzle. Every fossil found in layers dating back to Pangea is more than just a stone. It tells a story about the climate and environment that reigned on the planet millions of years ago. The bones of giant reptiles and the imprints of lush vegetation paint a world full of contrasts. Here, on the expanses of a single continent, humid, impenetrable tropical forests and lifeless, sun-baked deserts coexisted. But even more astonishingly, these ancient records show us how the slow but inexorable movement of continents drove evolution. As tectonic forces began to tear Pangea apart, geographic isolation became the very engine that launched the process of the birth of unique, inimitable species on each new continent. These fractured land masses are where the drama that led to the astonishing biodiversity we see today unfolded. Within these same rock layers, we also find the scars of great catastrophes, evidence of mass extinctions that reshaped the map of life on Pangea. Layers of sediment and fossils tell a silent saga of adaptation and the desperate struggle for survival in a world where climate and geography itself shifted with kaleidoscopic speed. These stone archives pose crucial questions about resilience and evolution, highlighting life's incredible ability to rise from the ashes even after the most devastating blows. The lessons we learn from the fossil record serve as a powerful reminder of how dynamic the history of our planet is. They open our eyes to the invisible threads that connect all living things and allow us to glimpse into a world that existed long before the first human appeared on Earth. Let's return once again to 300 million years ago to the vastness of the supercontinent Pangea. This single landmass provided a grand setting for understanding how ancient plants and animals migrated. Imagine a world where vast tracts of land are not separated by oceans, but flow seamlessly into one another, creating a single living space. For example, the Atlantic Ocean continues to widen, and the Americas are drifting further and further away from Europe and Africa. Geologists estimate that the entire process of Pangea's breakup took approximately 100 million years, a colossal period even by terrestrial standards. This history, spanning such a vast period of time, vividly demonstrates the dynamic and ever-changing nature of our planet. The remnants of this massive supercontinent testify to the power of tectonic forces and remind us of a time when Earth looked very different. The fragmentation of Pangea, which began approximately 200 million years ago, led to global changes in ocean currents, climate, and habitats. Distinct ecological zones emerged on the global map, which had a profound impact on biodiversity. Continents drifted apart and oceans expanded, creating entirely new sea routes. This not only affected temperature regulation across the globe, but also created new weather patterns. These changes inevitably affected nature. The new distribution of precipitation led to some areas becoming arid deserts, while others became lush tropical forests. This diversity of climates became a powerful impetus for evolution. Countless new life forms emerged, adapting to these new conditions. This led to an explosion of biodiversity, and the fragmentation of land created isolated laboratories of evolution, often paving the way for the emergence of completely unique and bizarre creatures. This unique planetary configuration provided ideal conditions for the movement of living organisms over vast distances. Species could spread across territories in ways that seem simply unimaginable to us today. For the plant world, Pangea was a true godsend. Global wind currents, unhindered by water, carried seeds and spores to the farthest reaches of the single continent. Plant seeds, buoyant as they were, could travel through inland seas and rivers, establishing new colonies on lands that millions of years later would become other continents. Large land animals, giant herbivorous lizards, also played a role in this process. By consuming the succulent fruits, they became unwitting gardeners, dispersing seeds across vast territories in their excrement. This symbiotic relationship between animals and plants nurtured genetic diversity and facilitated the adaptation of life across the vast expanses of Pangea. The animal world, too, was not static. Migration routes crossed a complex mosaic of landscapes, across full-flowing rivers, mountain ranges, and dense, dark forests. Each of these landscapes offered its own conditions and supported unique life forms. Ancient creatures were not confined to small patches of land. They were free to explore new horizons, adapting to a wide variety of ecosystems. When the climate changed, entire species uprooted themselves, embarking on long journeys in search of food or more suitable living conditions. This slow migration, stretching over generations, ultimately led to the emergence of entirely new species, which, on the one hand, were perfectly adapted to their new environment, but on the other, still carried the genetic memory of their common ancestor. But nothing lasts forever. Over time, tectonic plates shifted, and the monolith of Pangea began to crack. Around 175 million years ago, populations that had once been a single entity found themselves separated by growing faults and new oceans. Once united ecosystems became isolated islands of life. From that moment on, new rules came into play, the rules of island biogeography, which opened up entirely new evolutionary paths. And the legacy of these ancient migrations lives on in the descendants of those first species, scattered today across the globe. Each continent, with its unique inhabitants, is a living reminder of how deeply interconnected all life on our planet is. Surprisingly, the concept of Pangea, a single Earth that existed approximately 300 million years ago, is reflected in ancient human mythology. In many cultures around the world, we find legends and stories that seem to echo the idea of a primeval Earth where all living things were inextricably linked. This suggests that deep within humanity's collective memory, a vague image of a time when the world was one remains. This is particularly evident in creation myths and the origins of humanity. These stories are underpinned by the idea of the connection of all life, a golden age of harmony. For example, many Native American beliefs contain legends about a time when the earth was not yet divided by oceans, and animals, humans, and spirits spoke the same language and lived in peace. This sense of unity and interconnectedness strikingly echoes the scientific concept of Pangea. These myths reveal how ancient cultures perceived their relationship with the planet and with each other, sensing an interconnection that transcends all distances. Similarly, if we turn to African myths, we find stories of the Great Migration, the journey of ancestors from a common ancestral homeland. These tales can be seen as a metaphorical reflection of the movement of continents. Such stories not only speak of the actual migrations of early human populations, but also echo an era when the Earth itself was perceived as something more integral and homogeneous. The emergence of multiple cultures with a common mythological origin testifies to humanity's deep-seated desire for unity and understanding of its own history. The legacy of Pangea in these mythologies is a powerful reminder. Although the continents separated millions of years ago, the histories and cultures born on them remain connected by invisible threads. These ancient legends resonate in our consciousness, serving as a bridge that connects us to our distant past and strengthens a sense of unity based on a common origin. But the very idea of such a world continent was born not in ancient myths, but in the inquisitive mind of one man at the beginning of the 20th century. His name was Alfred Wegener. A German meteorologist and geophysicist, he was unconstrained by the dogmas of contemporary geology. One day, while examining a world map, he noticed something thousands had seen before him, but no one had paid attention to: a striking similarity between the coastlines of South America and Africa. They fit together like two pieces of a giant puzzle. This simple observation sparked a bold thought. What if these continents were once a single whole? He named this hypothetical supercontinent Pangea, which means whole Earth in Greek. Wegener's hypothesis wasn't based solely on visual similarities. He began collecting evidence, like a prosecutor preparing a case, and one of his main assets was fossil evidence. Fossils of Mesosaurus, a small freshwater reptile, were found in both Brazil and South Africa. How could this tiny creature have swum across the entire Atlantic Ocean? The answer was simple. There was no ocean between them. Similarly, fossils of the ancient fern Glossopteris were discovered on continents that are now separated by thousands of kilometers of icy water. This was irrefutable proof that these lands once shared a common history. However, despite the logic and power of his evidence, the scientific community met the theory of continental drift with hostility. What was once a bold hypothesis has now become a fundamental truth, revealing the eternally restless and dynamic soul of our planet. Let's travel back in time to 300 million years ago. At that time, there was neither the Atlantic nor the Indian Ocean. There was only one gigantic supercontinent, Pangea. This colossal landmass did more than just shape the geology of ancient Earth. Its legacy, its ghost, has permeated millions of years and even left its mark on human culture. Let's delve into the legends of ancient peoples, their sagas, passed down orally for countless generations. We find a rich oral heritage in many indigenous cultures around the world. These stories are imbued with a sense of an unbreakable, almost mystical connection with the earth. They encode a profound understanding of landscapes, animal migration routes, and the delicate balance of nature. The idea of Pangea, though not called by that scientific term, resonates surprisingly in their worldview. It reflects the memory of a golden age, a time when all land was a single, undivided home. For many of these peoples, the earth is not just the physical space beneath their feet, but a living, breathing being whose memory preserves the stories of their ancestors. The splitting of the continents, which we see on modern maps, can be represented in their myths as a great dispersion of tribes and communities, the beginning of their long and arduous journeys. These legends often speak of a profound connection to a specific land with its rivers and mountains. It can be assumed that as the tectonic plates moved apart, the paths of peoples likewise diverged, each culture acquiring its own unique identity, inextricably linked to a new, isolated ecosystem. The reverence with which ancient peoples regarded geographical features, imbuing them with spiritual power, is more than just a cultural tradition. Remarkably, some of these ancient tales echo our scientific understanding of continental drift almost verbatim. In many creation myths, we hear motifs of the movement, transformation, and rifting of land masses, a poetic description of the very geological processes that first assembled Pangea and then tore it apart. The wisdom of these traditions always emphasized the need to live in harmony with nature, demonstrating that ancient peoples could intuitively perceive the world as a unified whole long before modern science gave this phenomenon a name. Moreover, studying the history of Pangea today helps the descendants of those peoples, representatives of indigenous communities, better understand their past and prepare for the future, especially in the face of climate and environmental threats. Recognizing the colossal changes the continents underwent in the past, these cultures can develop new strategies for survival in today's rapidly changing world. Their dispersal across the planet is not a tragedy, but a confirmation of their incredible resilience and deep connection both to the planet itself and to each other. Thus, the great legacy of Pangea becomes a bridge connecting rigorous scientific research and vibrant cultural identity. It reminds us all of the endless, ever-changing saga of our planet and all its inhabitants. The Great Rift of Pangea, which began about 200 million years ago, was an event of truly planetary proportions. It wasn't just a geological drama, it was a cataclysm that forever changed the geography, climate, and ultimately, the very fate of life on Earth. Imagine this scene. A single landmass beginning to crack at the seams, gigantic faults cutting through it. As these fragments of the ancient world began their slow but inexorable drift, they not only gave birth to new oceans, raised new mountain ranges, and created unprecedented ecosystems. They laid the foundation for all the astonishing diversity of flora and fauna we see today. This transformation also had a colossal impact on the migration routes of our distant ancestors. As the continents drifted apart, completely different worlds emerged, each with its own climate and conditions. This forced ancient human populations to adapt and seek new ways to survive. For example, the separation of the American continents from Eurasia and Africa marked a great divide. The two worlds were isolated for millions of years. This led to life, and subsequently, human civilization, following its own unique path on each of these gigantic land masses, giving rise to an incredible diversity of cultures, languages, and traditions. The geographic barriers that emerged from this rift, boundless oceans and impenetrable mountain ranges, became the main actors on the stage of human history. For millions of years, they determined where our ancestors could go and which lands remained inaccessible. Continental shifts could either facilitate or hinder great migrations. Recall the Ice Age, when falling sea levels exposed a land bridge known as Pangea. This route, connecting Asia and North America, became the gateway to the New World for the first humans. On the other hand, the newborn oceans became insurmountable barriers, isolating entire populations for millennia, giving rise to unique cultures and languages. This is especially evident in the case of the island peoples of the Pacific Ocean, whose evolution and cultural development are directly linked to this ancient geological rift. So the split of Pangea isn't just a geology textbook fact. It's a key turning point in human history. It shaped the landscapes we call home, determined the paths of great migrations, and had a decisive influence on the development of all civilizations around the world. Ultimately, it was this monumental cataclysm that laid the foundation for the rich and varied tapestry of human history we marvel at today. Today, it is widely accepted that Pangea is a supercontinent that dominated the planet approximately 300 million years ago. This story, rooted in an inconceivably distant past, has captured the imagination of not only scientists, but also popular culture, giving rise to a multitude of vivid images. In documentaries, spectacular animations, and educational programs, Pangea is most often depicted as a gigantic island in a vast ocean, where the familiar contours of the continents merge into a single, unrecognizable whole. This visualization helps viewers not only grasp the scale of this geological phenomenon, but also experience its colossal significance for the history of our planet. The image of Pangea is more than just an illustration of plate tectonics. It's a vision of a world without the barriers created by oceans. It makes us wonder, what would life be like? How would ecosystems and climate zones interact without these gigantic water barriers? In film and television, the idea of Pangea often becomes a powerful plot device for exploring themes of unity and subsequent division. For example, some films and television series emphasize the fascinating evolutionary paths of ancient species, their adaptations to life on a single continent. We see scenes where dinosaurs roamed unhindered across vast landscapes from the future South Pole to the North Pole, and ancient plants thrived in a more uniform global climate. Imagine two worlds that took completely different evolutionary paths. When a giant rift finally severed the connection between what would become South America and Africa, countless species began a new independent journey through time. On these newly formed island continents, life took its own unique path, giving rise to incredibly rich and unique ecosystems. But this isolation also had a dark side. Unique flora and fauna, developing in isolation from the rest of the world, sometimes found themselves in a deadly trap. Some species simply couldn't adapt to rapidly changing conditions or found themselves cut off from migration routes. As a result, their gene pool dried up, leading inexorably to extinction. Meanwhile, on land, another geological drama was unfolding. We see incredible tectonic forces buckling the Earth's crust, lifting new mountain ranges skyward. Simultaneously, vast tracts of land subsided, forming deep valleys and basins. Each such event created entirely new conditions, new ecosystems, forcing living organisms to seek new ways of interacting with their surroundings. These geological ups and downs continued to influence the climate and diversity of life for many millions of years after the collapse of Pangea, leaving behind the legacy of a momentous event that marked a turning point in Earth's history. The Great Rift of Pangea was, without exaggeration, a key chapter in the biography of our planet. Let's travel back in time approximately 200 million years. These artistic interpretations create a vibrant and vivid picture of a dynamic, ever-changing Earth, encouraging viewers to reflect on the complex relationships between the environment and the organisms that inhabit it. Educational platforms also actively use the image of Pangea as an effective tool to engage young audiences in the study of geology and paleontology. Interactive maps and impressive animations help visualize the slow but dramatic movements of the continents that occurred millions of years ago. These presentations often emphasize that Pangea is not just a historical curiosity, but a key piece of our planet's vast geological puzzle. Understanding the history of Pangea helps us understand why the continents are positioned the way they are today, and how this impacts biodiversity and climate. Modern media don't dwell on the past. They show how these ancient geological shifts continue to shape our world today. They link the movement of continents to tectonic activity, earthquakes, and even climate change. Thus, in the hands of modern storytellers, the idea of Pangea transforms from a dry scientific concept into a captivating narrative about the past, present, and future of our planet. The saga of the supercontinent Pangea, which existed more than 300 million years ago, is more than just a tale from the distant past. It holds important lessons for modern society. This ancient Earth is a clear example of how change and adaptation are the primary driving forces in our planet's history. When Pangea began to break apart, it triggered a cascade of catastrophic consequences for the climate, habitat, and evolution of all life on Earth. Understanding the scale of this dramatic transformation, we begin to understand the vital importance of adapting to change. Like those ancient species that managed to survive by developing new strategies in a changing environment, our society must be flexible and resilient to thrive in the face of constant challenges, whether global warming or technological revolutions. The story of Pangea also instills in us the belief that even after the greatest upheavals, life can find new paths to prosperity and harmony. Consider the interconnectedness of all life. During the Pangean era, different regions were connected, allowing animals and plants to migrate freely over vast distances. The subsequent split led to isolation and the emergence of unique evolutionary lineages that today populate the diverse ecosystems of our planet. This lesson from the past teaches us the importance of global cooperation to address the most pressing challenges of our time, whether climate change, pandemics, or equitable resource management. The health of the entire planetary ecosystem depends on the health of each of its interconnected parts. Likewise, humanity must work together across borders to address the most complex global challenges. Moreover, the breakup of Pangea was accompanied by incredible geological activity. New mountain ranges rose from the Earth's depths. Powerful earthquakes rocked the planet, and volcanic eruptions altered the composition of the atmosphere. These events serve as a stark reminder that Earth is a dynamic and constantly evolving system, and it is crucial for us to understand our role in this monumental process. The lessons of Earth's geological history call us to a deeper understanding of our place in the world. Let us travel back in time to an era that holds fundamental lessons for all humanity. The story of Pangea is more than just a tale of shifting rock and tectonic plates. It is a grand narrative of unity, of inevitable disintegration, and of the colossal forces of nature that shape worlds. This story serves as a reminder, almost a whisper, from the prehistoric past. Every action we take leaves a mark that echoes through the ages, influencing the fate of the planet far beyond our brief moment in the sun. To understand this saga, we must learn to read the great book of Earth itself. Its pages are layers of geological rock. Its writings are the fossilized remains of ancient creatures, and its language is science. Geology, paleontology, and climatology are the tools that allow us to decipher the past and peer into the very heart of our world. Every fossil fragment, every layer of sedimentary rock becomes the key to understanding the structure of our planet. This knowledge engenders a profound respect for scientific inquiry and for education as the only reliable foundation for our future. In a world racing forward, facing ever more complex challenges, the lessons of Pangea resonate especially clearly. They tell us that only by understanding our past and the past of our planet can we find the right path to a sustainable and interconnected tomorrow. Imagine a world completely unlike our own. 300 million years ago, in the late Paleozoic, the inexorable dance of the continents reached its climax. Vast land masses, drifting across the planet for millions of years, collided in a titanic embrace, creating a single, gigantic supercontinent. Its name is Pangea. But in this ancient world, as in our own, nothing lasted forever. About 175 million years ago, already in the early Mesozoic, deep forces raging within the Earth's depths began to tear this giant apart. This planetary rift was an event that forever changed the face of the Earth. New coastlines were born, young mountain ranges rose from the depths, and great rivers carved new channels to distant oceans. For the ancient civilizations that would emerge after an unimaginable amount of time, this legacy of Pangea would create both insurmountable barriers and unprecedented opportunities. The continental split didn't just redraw the map, it reshaped the very fate of future life. Land bridges appeared and disappeared, which during the Ice Ages had allowed ancient tribes to undertake enormous migrations, traversing vast distances with unprecedented ease. These great migrations became the engine of progress, enabling the exchange of ideas, languages, and technological advances that had previously been the preserve of isolated groups. But as the continents drifted further apart, once united communities found themselves separated by oceans. This isolation, in turn, gave rise to complex social networks and opened new horizons for interaction and understanding between peoples. Over millennia, this geological process created unique ecosystems in various corners of the planet, rich in their own unique natural resources. For traders and early civilizations, this meant that the world had become a gigantic treasure trove. Valuable goods, such as spices, rare metals, and exotic fabrics, could now be found only in certain distant lands. This sparked the birth of the first international trade networks. Legendary trade routes were established, linking the flourishing civilizations of Africa, Europe, Asia, and later the Americas. These arteries carried not only goods, but also culture. Societies enriched one another by exchanging technologies, art, and philosophical ideas. The split of Pangea forced ancient seafarers to completely rethink their strategies. When land travel became impossible, they turned to the sea. Coastal trade routes became crucial. The Mediterranean, for example, eventually became a vital maritime crossroads, a cauldron of trade where great civilizations were born and destroyed. Thus, the legacy of Pangea, this long-vanished world, shaped human development, creating a complex web of relationships that still forms the very essence of our shared history. Now, let's take a moment to consider a thought experiment. Try to imagine an alternative reality, a world in which humanity emerged and developed not on disparate continents, but on a single, gigantic landmass, Pangea. Of course, humans didn't exist back then, but such a fantasy helps us better understand how geography and climate shape culture. Pangea would have been a world of incredible diversity. Just imagine its landscapes. Arid, sun-baked deserts would have stretched across the supercontinent's heart. The peoples living there would have developed unique ways of surviving, their cultures forged in the struggle against the elements. Now, let's move to the coast. Lush, humid, tropical zones teeming with marine life. Here, entirely different civilizations would have flourished, their lives inextricably linked to the ocean. Each human group would have developed its own unique culture in response to environmental challenges, and this would have influenced everything from diet and clothing to art and religion. Moreover, thanks to the absence of ocean barriers, this world would be incredibly interconnected. Even the most remote tribes would be able to interact, trade, and exchange knowledge. This would lead to the emergence of a rich mosaic of cultural practices where ancient traditions would blend with new ideas, constantly evolving and transforming. Imagine this swirling cauldron of stories, agricultural techniques, and artistic styles circulating across the continent. However, once Pangea began to disintegrate, this picture would have changed. The resulting isolation would have become a powerful catalyst for the formation of unique cultural traits. As the giant land masses drifted apart, the separated peoples would have begun to adapt to new local conditions. This would have led to even greater cultural diversity, demonstrating the delicate balance between unity and isolation that defines all of human history. The discovery of Pangea's very existence was one of the greatest breakthroughs in our understanding of the planet. This concept fundamentally changed geology and forced us to rethink the dynamic nature of the Earth's surface. For a long time, scientists were convinced that the continents were immobile, like giant anchors driven into the Earth's mantle. But new data, like pieces of a giant puzzle, forced us to reconsider this dogma. The realization that the continents are moving, that they were once a single entity, revolutionized science. The theory of plate tectonics, which explains how the Earth's crust is divided into enormous plates floating on a semi-liquid mantle, has received irrefutable evidence. The history of Pangea revealed that the movement and interaction of these plates causes earthquakes, volcanic eruptions, and mountain formation. Scientists pieced together a picture of the past, understanding how these processes shaped our planet over millions of years. We realized that continental drift is an ongoing process that continues to reshape the Earth today. The discovery of Pangea also shed light on the mysterious distribution of fossils. Fossils of the same species of ancient animals and plants that lived thousands of years ago were found on completely different continents, separated by oceans. This provided direct evidence that these regions were once connected, allowing fauna and flora to migrate freely. The striking similarities of geological formations, such as the mountain ranges in South America, Australia, and Africa, further supported the theory. They clearly descended from a single ancient landmass. Moreover, studying Pangea has opened our eyes to the climate changes that have occurred throughout history. After all, the configuration of the continents directly influences the ocean currents and atmospheric flows that shape the global climate. By analyzing the prehistoric climate of the supercontinent, scientists gain invaluable data that helps them predict possible future climate scenarios. Thus, studying Pangea is more than just a glimpse into the distant past. It is the key to understanding the processes that will shape the future of our planet. Ultimately, the myth of ancient Pangea is more than just geology. It's a profound idea of the interconnectedness of all things. The very concept of a single supercontinent that existed hundreds of millions of years ago ignited an insatiable thirst for discovery and exploration in humanity. The idea that all the continents were once connected fired the imagination, prompting speculation about what that ancient world was like in terms of culture, resources, and biodiversity. When the first explorers set sail across uncharted oceans, This myth served as their guiding star. The realization that ancient connections might exist between the most distant lands prompted a deeper study of how different cultures developed and interacted. The hypothesis that the world is far more interconnected than it initially appears encouraged exploration rather than isolation. The concept of Pangea played a key role not only in the development of science, but also in shaping our worldview, reminding us of our common planetary origins. At that time, Earth was dominated by a single colossal supercontinent, which scientists have named Pangea. Its vast expanses contained virtually all of the planet's terrestrial life. However, this stability was only apparent. Deep within the Earth's core, driven by the immense heat of its core, plate tectonics were already gathering strength, slowly but surely preparing for a great upheaval. And so, Pangea, this monolithic world, began to crack at the seams. The landscape began to change beyond recognition. Titanic tectonic movements forced parts of the supercontinent apart. Between them, a new ocean was born, the Atlantic, forever dividing what would one day become North and South America, Europe, and Africa. This process stretched over tens of millions of years, and it was not silent. The planet was rocked by monstrous earthquakes, volcanoes erupted with lava flows, and gradually, millimeter by millimeter, the outlines of future continents emerged. These geological shifts created new oceans, shaped coastlines, and radically altered climate patterns across the globe. The simple shift in the geographic position of land masses caused by the breakup of Pangea had a colossal impact on the course of evolution and the entire biodiversity of our planet. Ecosystems isolated on the broken-off land masses became unique evolutionary laboratories. Unique plant and animal species arose here, ultimately leading to the astonishing diversity we see today. Consider Madagascar, which, like a giant arc, drifted off the African coast, allowing such amazing creatures as lemurs to evolve in complete isolation. Similarly, the rift between South America and Africa triggered evolutionary processes that gave rise to the vastly different wildlife on either side of the Atlantic. Thus, the breakup of Pangea is more than just a geological event. It is a key act of creation, shaping not only the face of the Earth, but also its entire biodiversity. And this process hasn't stopped. It continues today as Africa and South America continue to slowly drift apart. This perpetual motion reminds us that our planet is a living, breathing organism, constantly in flux. Studying these monumental transformations of the past gives us the key to understanding not only how our continents came to be, but also what their future will be. The supercontinent that existed approximately 300 million years ago was one of the greatest events in Earth's geological record. To peer into this distant past, modern scientists are using a whole arsenal of cutting-edge technologies. These technologies allow them to reconstruct, literally bit by bit, how our planet's continents drifted apart over millions of years. One of the key tools in this research is plate tectonic modeling. Imagine powerful computers creating digital twins of the ancient world. They visualize the movement of tectonic plates based on modern geological data. This allows scientists, like in a time machine, to rewind history and see exactly how the continents were positioned at a particular era. This modeling helps us understand the specific forces hidden deep within the Earth, for example, mantle convection or gravity, that drove the giant plates to move. Geophysical instruments also play a crucial role in reconstructing the ancient Earth's appearance. A network of sensitive seismic sensors like giant ears listens to the planet's pulsations, measuring earthquake waves. By analyzing how these waves travel through the planet's crust, researchers can create a detailed map of the Earth's crust and pinpoint the precise boundaries between tectonic plates. This data sheds light on how the continents were joined together as part of Pangea, and along what seems they ultimately broke apart. Another astonishing technology is satellite geodesy. Using global positioning systems like GPS, scientists measure the movement of the Earth's surface with incredible precision right now. This allows us to see the rate at which modern continents continue to drift and compare these data with historical data. This ongoing monitoring not only enriches our knowledge of the breakup of Pangea, but also allows us to peer into the future, predicting future geological changes and gaining a deeper understanding of the dynamic nature of our world. Fossil evidence has been and remains a key element in deciphering Earth's history, particularly when it comes to the breakup of Pangea, the supercontinent that dominated the planet approximately 300 million years ago. This single landmass eventually split apart, giving rise to the continents we know today. The combined work of paleontologists and geologists has allowed fossils to piece together a compelling story of how life was distributed across these now separated parts of the world. One of the most striking pieces of evidence is the discovery of identical fossils on continents that are now separated by thousands of kilometers of ocean. Imagine fossils of Mesosaurus, a small freshwater reptile, have been found in both South America and Africa. But this creature was simply physically incapable of crossing the vast expanses of saltwater ocean that now lie between these continents. The only logical explanation is that these lands were once a single entity, allowing Mesosaurus to roam freely across vast territories. A similar story unfolds in the plant world. Fossils of the ancient fern Glossopteris have been found in diverse locations around the world: South America, Africa, India, Australia, and even icy Antarctica. This plant could only thrive in temperate climates, which would have been impossible had these continents been separated by oceans, as they are today. The presence of such fossils in such diverse landmasses is irrefutable evidence that Pangea was once a single, unified ecosystem, an ecosystem that began to change as the continents drifted apart. These findings not only confirm the theory of continental drift, but also help scientists understand the colossal climatic and environmental changes that followed the breakup of Pangea. These rocky witnesses highlight how closely intertwined life on Earth was during that ancient period, a period that demonstrates the power and dynamism of our planet, which underwent monumental transformations to ultimately become the multifaceted world we live in today. The breakup of Pangea, the ancient supercontinent, which began approximately 250 million years ago, caused a real upheaval not only on land, but also in the world's oceans. The formation of the modern continents led to profound changes in ocean currents and coastlines. One of the main consequences was a complete redistribution of heat and nutrients in the oceans, which in turn forever altered the marine environment and all its ecosystems. The key moment was the birth of new ocean basins. Imagine how the divergence of tectonic plates opened up gigantic basins, including what would become the Atlantic Ocean. This completely redrew the current map. Water circulation dynamics became completely different. Warm waters from the equator rushed along new routes, exerting a powerful influence on climate and weather patterns across the planet. The continents, which had been moving toward each other for millions of years, began to collide. It was a collision of truly planetary proportions. The edges of the continents crumpled like paper, rising upward to form grandiose mountain ranges. The driving force behind this process were convection currents in the mantle, giant swirls of molten rock that, rising and cooling, dragged tectonic plates along with them. The key moment in the creation of Pangea was the titanic collision of two ancient supercontinents, southern Gondwana and northern Laurasia. This final act of the geological drama completed the formation of a single landmass. Pangea was washed on all sides by the waters of a single gigantic ocean known as Panthalassa. But life on this supercontinent was not peaceful. The unification of all the land masses in one place created incredible stress on the Earth's crust. Powerful earthquakes constantly rocked Pangea's surface, and volcanoes spewed streams of ash and lava into the atmosphere. It was a world born of fire and movement. However, nothing lasts forever. About 200 million years ago, the same forces that created Pangea began to tear it apart. The Mesozoic era witnessed this monumental rift, which ultimately shaped the planet as we know it. This event didn't just change geography, it forever altered the course of evolution, creating new, isolated worlds where life took its own unique paths. The movement of tectonic plates also posed a challenge to marine life. To survive, they had to adapt to new habitats, spurring evolution and leading to the emergence of numerous unique species. Furthermore, the separation of continents created isolated marine regions where life could develop along its own unique path, relatively safe from external threats. This isolation contributed to the preservation and growth of biodiversity in the oceans, as different species began to specialize, adapting to their unique ecological niches. For example, coral reefs began to flourish in the newly formed shallow seas, while other organisms colonized the deeper areas created by plate movement. As a result, the marine landscape became much more diverse and complex. Ecosystems emerged that never existed before the breakup of Pangea. It was this monumental geological process that laid the foundation for modern ocean geography and the incredible diversity of life hidden in the deep sea. This momentous event left a legacy that we still see today. We can observe the astonishing consequences of this monumental geological upheaval. The complex laws of ocean currents and the incredible wealth of marine biodiversity are a direct legacy of those times, continuing to shape the ecosystems of our oceans. Understanding how these systems evolved in the distant past provides us with invaluable insights into the health of our planet's oceans today and the fate of the organisms that inhabit them. The story of the supercontinent Pangea is a saga spanning 300 million years. About 300 million years ago, most of Earth's landmass was fused together, forming a single, gigantic geological formation. Before the Great Rift began, all the future continents were welded together into a massive land mass stretching from pole to pole. Imagine the world as it was hundreds of millions of years ago. In that distant era, all of our planet's land mass was fused into a single, colossal supercontinent stretching from one icy pole to the other. Its name is Pangea. This gigantic landmass dictated the climate, directed ocean currents, and determined how animals and plants spread across the planet. It gave birth to harsh, lifeless deserts, scorching with heat, dense, humid forests teeming with ancient life, and majestic mountain ranges. Mountains stretched in continuous chains, linking distant lands together. Thanks to this, life across the vast territory of Pangea was remarkably uniform. But nothing lasts forever, and approximately 180 million years ago, titanic forces slumbering in the bowels of the planet awakened. The great supercontinent began to crack at the seams. The Great Rift had begun. Slowly but inexorably, giant land masses began to move apart, opening the way for new oceans. This process radically changed the face of the planet, its geography, and ecosystems. Where there had once been a dry land, new coastlines were now emerging. Ancient landscapes were submerged or transformed beyond recognition. For example, between what would become North America and Europe, a chasm opened up, eventually becoming the Atlantic Ocean. This split forever severed the connections between ecosystems. Living creatures that had once been neighbors found themselves separated by insurmountable water barriers. Evolution on each of these new continents followed completely different, unique paths. After Pangea finally broke apart, the continents slowly drifted toward their present locations, acquiring the shapes we know today. This drift didn't simply change the map of the world. It reshaped climate zones and forced ocean currents to move in new ways, creating unique natural conditions in different parts of the Earth. Coastlines continued to shift, and the oceans between land masses grew ever wider. Species isolated on their continental islands began to adapt to the new conditions, leading to an incredible explosion of biodiversity. Today, we see the echoes of this great divide. Look at Australia. Its ecosystems are radically different from the rest of the world. Frozen Antarctica became home to its own unique flora and fauna. Africa became a cradle for the planet's largest land animals, and the differences between the flora and fauna of North and South America still harbor memories of a time when they were part of a single whole. The fragmentation of Pangea is a great drama that shaped geography, climate, and the astonishing diversity of life we see today. The evolutionary paths taken by life on each continent paint a captivating picture of a dynamic and ever-changing nature. Each shift of a tectonic plate over millions of years was more than just a geological event. It laid the foundation for a new chapter in the book of life. And that book is still being written as scientists continue to study the history of ancient supercontinents to fully understand how our planet was created. How can we, hundreds of millions of years later, peer into this distant past? Today, geologists use a wide range of scientific disciplines and advanced technologies to unravel the mysteries of continental movement. One key method is the theory of plate tectonics, which describes the movement of giant crustal slabs under the influence of gravitational forces deep within the planet. By understanding how these plates danced over millions of years, researchers are piece by piece reconstructing the complex history of Pangea's birth and demise. Another powerful tool is paleomagnetism. When volcanoes erupt, their hot rocks contain magnetic minerals. As they cool, these minerals align themselves with the Earth's magnetic field, like tiny compass needles frozen forever. By studying the orientation of these ancient rocks, scientists can determine, with remarkable accuracy, the latitude of a given landmass at the moment of its formation. This provides invaluable information about the relative positions of the continents in ancient times. Of course, it's impossible to imagine this work without geological mapping and detailed analysis of rock layers. Sedimentary rocks are especially important. They are the Earth's true stone record. By studying them, scientists can uncover the history of climate change and learn about past ecosystems. This helps reconstruct how the world around us has changed since the time of Pangea. And the fossils found in these layers, like the main characters in this drama, tell us about the flora and fauna that once flourished on this single continent. Finally, in the 21st century, the power of computer modeling has come to the aid of geologists. These technologies allow us not just to hypothesize, but to literally visualize the dynamics of continental movement, opening up entirely new horizons in our knowledge. Complex models take into account a multitude of factors, from tectonic forces to geological processes, and allow us to create scenarios demonstrating what ancient Pangea looked like and how it lived. Thanks to all these methods, we can journey into our planet's past and gain a deeper understanding of the colossal forces that shaped our world over hundreds of millions of years. Our knowledge of Pangea, the ancient supercontinent that existed some 300 million years ago, has evolved alongside science and technology. At the dawn of geology, scientists could rely only on their own eyes and simple geological observations to piece together the gigantic puzzle of continental drift. The first clues were strikingly simple and ingenious. They noticed that the coastlines of different continents, such as Africa and South America, matched each other like pieces of a puzzle. This was further reinforced by the discovery of identical fossils and similar rock layers on continents today, separated by thousands of kilometers of ocean. This monumental work laid the foundation, pointing to a distant past when all land was a single entity. But a complete picture emerged only in the mid-20th century with the birth of the revolutionary theory of plate tectonics. This was a turning point that forever changed our understanding of the planet. The theory explained that the Earth's crust, the lithosphere, is not monolithic, but divided into several giant plates that literally float on a semi-liquid layer of the mantle beneath. Armed with this concept, scientists were finally able to explain the movement of continents, the nature of earthquakes, and volcanic eruptions. With each new study, data accumulated, confirming that the continents are not static boulders, but dynamic participants in a vast geological process driven by the forces of plate tectonics. With the advancement of technology, scientists have acquired new, incredibly powerful tools. Views from space and satellite images have allowed us to deepen our understanding of the Earth's structure and its turbulent history. High-resolution images processed using sophisticated computer models have opened up new horizons in ocean floor mapping. We've been able to see what lies beneath the ocean floor, giant mid-ocean ridges where new crust is born, and deep-sea trenches, subduction zones, where old crust plunges back into the mantle. These tectonic plate boundaries are what define them. These data, coupled with seismic images that allow us to peer deep into the Earth's crust, have helped scientists reconstruct the dance of the continents with unprecedented accuracy and understand the processes that led to the birth and breakup of Pangea. Today, thanks to computer modeling and the analysis of massive data sets, we can study the history of this supercontinent in detail. Our view of that era has become much more complex and expansive. We can literally see what the continents looked like millions of years ago and understand the climatic and biological dramas that played out across their vast expanses. With each technological breakthrough, with each new research method, our understanding of Pangea and the colossal forces that shaped it deepens. And this, in turn, paints an ever clearer and more captivating picture of our planet's past. Space observations have revolutionized our understanding of Earth's ancient geography, particularly when it comes to the supercontinent Pangea. Using advanced technologies such as remote sensing and radar systems, scientists can trace the geological scars left by Pangea and gain invaluable insights into its structure and movement. These cosmic eyes allow researchers to measure ancient landforms, analyze geological features, and study the tectonic shifts that shaped our planet over millions of years. One of the most significant contributions of satellites to this field is their ability to map the Earth's surface in astonishing detail. Geologists can pinpoint ancient coastlines, long eroded mountain ranges, and other key landscape features with remarkable precision, then compare them with modern geography. These comparisons help us understand how the continents have moved, collided, and drifted apart since the great breakup of Pangea began about 200 million years ago. Continental drift is key not only to the history of our planet, but also to understanding geological processes that continue unabated even today. Satellite data allows scientists to record subtle changes in the Earth's crust that may indicate ongoing tectonic activity. By studying these movements dynamically, researchers can build a more complete and vivid picture of how Pangea functioned. They can track the speed of plate movement and visualize Earth's ancient history in real time. These ancient land and sea configurations provide an incredibly vivid backdrop for the grand story of evolution. Satellite observations also play a key role in reconstructing ancient climates. By analyzing fossilized plant remains and the structure of sedimentary rocks, scientists can determine the climate conditions that prevailed in specific regions of Pangea. This comprehensive understanding not only helps reconstruct geography, but also imagine the ecosystems that flourished during that distant era, clearly demonstrating how changes in the world map directly influence the course of biological evolution. Overall, the role of satellite technology in studying Pangea is a striking example of how modern science is constantly pushing the boundaries of our understanding of Earth's complex and dramatic past. As scientists strive to fully understand the mysteries of this ancient supercontinent, imagine being able to peer back in time 300 million years ago and see a world that is long gone. Today, This has become possible thanks to the remarkable union of sciences, geology, paleontology, and the most advanced computer technology. In the sterile silence of laboratories, scientists don't just study the past, they recreate it bit by bit. Like detectives investigating a multi-million-year-old case, researchers are collecting geological evidence, samples of ancient rocks and sediments dating back to the era when the single supercontinent of Pangea existed on Earth. Every stone, every layer of silt is a silent witness that can reveal the climate of that time, the ecosystems that flourished then, and how the geography of this gigantic continent influenced life itself. Then the real digital magic begins. Complex climate models are launched in virtual space, reconstructing the atmospheric conditions of Pangea like a time machine. These programs take into account everything: air temperature, precipitation, and even the direction of the winds that swept across the vast expanses of the supercontinent for centuries. They allow us to see that the climate across much of what is now the United States was significantly warmer. Researchers can trace differences in temperature and humidity across Pangea, gaining a clear understanding of how the ancient climate dictated its laws, determining where dense forests would grow and where vast deserts would spread. This is key to understanding the distribution of flora and fauna across this vast landmass. But to bring this world to life, landscapes alone aren't enough. It needs to be inhabited. This is where paleobiology, the study of ancient life, comes into play. Fossils and other biological traces of the past help us see the incredible plant and animal species that inhabited Pangea. Scientists go even further. In specialized labs, they grow the descendants of those ancient plants under carefully controlled conditions. At the heart of this eternal cycle of creation and destruction lie processes occurring at the boundaries of tectonic plates. Where plates collide head-on, so-called convergent boundaries form. Here, the Earth's crust is folded, giving rise to mountain ranges like the modern Andes. Where the plates move apart, divergent boundaries arise. Magma rises to the surface at these faults, cools, and creates new oceanic crust, as occurs at the mid-Atlantic ridge. A process known as subduction played a particularly important role in the merging of the continents. Imagine that upon collision, one denser tectonic plate begins to dive beneath the other, sinking back into the molten mantle. This process not only triggers powerful volcanic activity, but also literally pulls the continents together, closing off ancient seas and oceans until the land masses merge into a single whole. But the forces weren't just acting on the surface. From the depths of the mantle, gigantic bubbles of superheated material, mantle plumes, rose. Reaching the crust, they burned through it, triggering colossal eruptions and contributing to the breakup of the continents. Ultimately, it was this internal dynamics of the Earth, this perpetual motion machine, that first assembled and then disassembled Pangea. And although the supercontinent itself has long since disappeared, its ghostly legacy remains visible today. By observing their growth, they can hypothesize how these organisms survived and thrived in the harsh world of the past. This allows us to literally peer into prehistoric jungles and imagine the sheer biodiversity that once reigned on the supercontinent. Sedimentology also plays a crucial role in this reconstruction. By analyzing ancient sedimentary rock layers, scientists, as if reading the pages of a stone chronicle, gain invaluable information about the environment. They study how these deposits formed, what minerals they contain, and how all this influenced the climatic conditions that ultimately shaped Pangea. This comprehensive approach reveals not just a physical map of the ancient world, but also its living, breathing, and dynamic ecosystems, enriching our understanding of the distant past. Recent discoveries have revolutionized our understanding of Earth's geological history, particularly Pangea, the ancient supercontinent that dominated the planet approximately 300 million years ago. By studying geological formations, fossils, and the movement of tectonic plates, we have uncovered a far more complex and sweeping picture. It turns out that Pangea was not just a single event, but merely one act in a grand drama of cyclical continental drift. This means that for millions of years, the Earth's crust was in constant flux. Oceans were born and died, and continents came together in a deadly embrace and then drifted apart again, slowly but surely, shaping the world we see today. Fossil evidence scattered across the planet played a key role in understanding this global connection. Paleontologists discovered identical species of ancient animals on continents that are now separated by thousands of kilometers of turbulent ocean. This provided irrefutable evidence that these lands were once a single entity. These vast land masses were part of a single supercontinent, Pangea. For example, fossils of the ancient reptile Mesosaurus have been found in both South America and Africa. This striking similarity suggests only one thing. In that distant era, these two continents were tightly connected, allowing these creatures to roam freely across the territories now separated by the Atlantic Ocean. Another exciting discovery involves the study of ancient climates, information about which is literally locked in layers of rock. These rock archives reveal weather conditions in regions that were once part of Pangea, giving us insight into how this giant continent influenced global weather. Perhaps the most striking example is the coal deposits in Antarctica. Today, it's an icy desert, but the coal is direct evidence that this region was once covered in lush, dense forests and enjoyed a warm, temperate climate. Such finds help scientists better understand the colossal ecological impact of the configuration of the continents. Moreover, modern technologies such as high-precision satellite measurements and powerful computer modeling have allowed us to literally see this dance of the continents. These instruments visualize how lithospheric plates shifted and rotated over millions of years, ultimately leading to the breakup of Pangea, which began approximately 200 million years ago. Remarkably, this movement continues to this day, shaping our planet and reminding us that its surface was never static. These discoveries have enormously enriched our understanding of the complex history of Pangea and its long-term impact on our world. Today, computer models play a key role in studying this ancient supercontinent and its epic breakup. Using the fundamental principles of plate tectonics, scientists can run simulations that show the movement of gigantic sections of the Earth's crust over millions of years. These models are built on a vast array of detailed geological data, allowing researchers to create incredibly realistic scenarios of the past. Before our very eyes, we can see how continents drifted, collided, crumpled into mountain ranges and drifted apart, redrawing the map of the world throughout its geological history. These simulations are based on the movement of lithospheric plates, these giant rafts of the Earth's crust. They float on the surface of the semi-liquid asthenosphere, and even the slightest temperature changes deep in the mantle can lead to colossal movements over geological time. Using computer models, scientists can input various data, mantle temperature, the forces acting on the plates, and observe in accelerated time how these factors contributed to the slow formation and then inevitable breakup of Pangea. These models are so complex that they can even account for geological events such as supervolcanic eruptions or the formation of mountain ranges. These factors influence not only the movement of tectonic plates, but also global climate, sea levels, and consequently, the planet's biodiversity over entire eons. Computer modeling helps us understand the past. Researchers use it to assess how changes in one part of the Earth can trigger a chain reaction and affect another. This allows for a more complete and interconnected understanding of the geological chronology of our planet and its turbulent history. Understanding the complex history of our world, the story of Pangea's breakup, is more than just a story about drifting continents. These models reveal the dynamic and incredibly interconnected nature of all Earth systems. They help us understand the powerful natural forces that have shaped the world we live in today over hundreds of millions of years. Reconstructing the precise history of Pangea, the supercontinent that existed approximately 300 million years ago, is a task of incredible complexity, a true scientific conundrum. First, the Earth's geological record is, to put it mildly, incomplete. Imagine a book from which entire chapters have been torn out. Ancient rock formations may have been completely destroyed by erosion or buried so deeply under new layers of sediment that they are virtually impossible to reach. Researchers strive to reconstruct a complete picture of the past, but not all geological events have left any traces behind. This rock record contains enormous gaps that hinder a common understanding. Another critical issue is the constant movement of tectonic plates. The Earth's surface is not a static picture, but a living, constantly changing organism. Continents shift, and over millions of years, this movement completely obscures their original positions. This presents scientists with a formidable challenge: how to reconstruct their positions in ancient times. To do this, they must rely on a comprehensive set of geological data, paleontological finds, and the laws of plate tectonics to draw conclusions about how these massive shifts occurred. But sometimes, the same data can lead to completely different interpretations and hypotheses about what exactly Pangea looked like. Fossil remains are a crucial clue in this historical puzzle, but they are not without their challenges. For example, the discovery of similar fossils on distant continents almost certainly indicates that these land masses were once connected. However, the exact routes of their movement and the geography of that world remain unclear. Studying ancient organisms requires a careful examination of the environments in which they lived, but fossil records can spark heated debate among scientists when it comes to the precise age, distribution, and ecological context of these organisms. Certainly, modern technologies such as satellite imagery and computer modeling have significantly advanced our understanding. Yet, geology remains a complex science, operating over vast time spans. Slow, almost imperceptible processes of geological change over millions of years lead to colossal transformations, generating significant uncertainty. But despite all these obstacles, every new discovery, every fossil found adds another piece to this gigantic mosaic. With each passing year, we better understand how Pangea formed, how it existed, and how it ultimately disintegrated, creating the world we know today. Today, interdisciplinary research plays a key role in deepening our understanding of the ancient supercontinent Pangea. This major scientific investigation unites the efforts of specialists from various fields. By combining findings from geology, paleontology, and paleoclimatology, scientists have been able to create a much more complete and vibrant picture of this fascinating period in the history of our planet. Geology helps researchers understand how this massive landform arose and what forces compressed the continents into a single whole. Let's look deep into time, to an era when the very geography of our planet was completely different. To understand the colossal impact this had on all life, scientists today must become true detectives of the past, studying ancient rock strata and traces of titanic crustal movements. A captivating picture of a world unfolds before us, where continents, now separated by thousands of kilometers of ocean, were once fused into a single, colossal monolith. And the most compelling evidence comes from paleontology. Fossils, these stone imprints of bygone eras, serve as invaluable witnesses. They tell us stories of how entire species of plants and animals emerged and evolved. These creatures roamed freely across vast territories that had not yet been torn apart by the great rift of Pangea. Imagine for a moment, paleontologists are unearthing fossils of very similar creatures, but they're doing so on continents that are now separated by a vast ocean. For example, the bones of the same ancient lizards are found in South America and Africa. How is this possible? There's only one explanation. These gigantic land masses were once inextricably linked, part of a single supercontinent, the legendary Pangea. By tracing the evolutionary response to changing climate and geography during and after Pangea's breakup, researchers gain insight into the profound laws of life and death for entire species. Paleoclimatology, the study of ancient climate, completes this picture by charting the weather patterns of those times. By analyzing layers of ancient sediments and ice cores from ancient glaciers, scientists reconstruct past climates that directly influenced ecosystems and the habitats of various creatures. This multifaceted study highlights how interconnected everything in the world is: climate, geography, and biology. It allows us to piece together the grand mosaic of Earth's history, something that would be impossible within the confines of a single scientific discipline. Each of these sciences contributes its own piece to the overall picture, which not only sheds light on the birth and demise of Pangea, but also helps us gain a deeper understanding of the processes that shape our world to this day. Studying this great rift not only reveals the secrets of the past, but also gives us an understanding of the global forces that shaped our planet. It becomes clear that understanding the world requires going beyond our usual frameworks. And as we delve into the mysteries of Pangea, this ancient world that united almost all land masses, we find ourselves on the threshold of incredible technological breakthroughs. One such revolutionary tool is advanced satellite imaging. It has the potential to radically change our understanding of how Pangea formed and disintegrated. This remarkable technology allows us to create maps of the Earth's surface in incredible detail. As if looking down from the gods, scientists can analyze the smallest geological features, track subtle shifts in the landscape, and reconstruct ancient habitats with unprecedented accuracy. This can show us how the face of Pangea changed over millions of years. Another promising technology is geophysical imaging. Using methods such as seismic tomography, researchers have learned to peer beneath the Earth's crust, into the very heart of the planet. This allows us to literally see the structure and composition of giant tectonic plates. This approach not only deepens our knowledge of Pangea's past, but also sheds light on the processes that continue to shape our world in real time right now. By understanding these deep mechanisms, we can reconstruct how the continents drifted apart in the past and even speculate on how they might reconverge in the distant future. Genetics, and especially the study of ancient DNA, has the potential to revolutionize our understanding of the flora and fauna of the Pangea era. Modern advances in genome sequencing allow scientists to extract genetic material from fossilized bones and even ancient soil deposits. This information, like a secret message from the past, tells us about the evolution of entire ecosystems during the breakup of the supercontinent, revealing the richness and diversity of life at that time. The preserved remains of ancient creatures are a chronicle of worlds that flourished amid unprecedented global unity. Climate conditions and the adaptability of species provide us with a clear understanding of the very mechanisms of evolution. The collaboration of scientists from various fields, armed with the power of artificial intelligence, makes it possible to process enormous amounts of data, climatic, geological, and biological. These technologies reveal hidden patterns and connections that previously remained invisible to the human eye. And as we accumulate more information, intelligent algorithms can help us predict how similar tectonic shifts may occur in the future, or how they affected the climate and life on the planet in the past. Thanks to modern technology, our understanding of these grand processes continues to grow, and the history of Pangea becomes ever more complex, detailed, and fascinating. Modern geological maps are more than just diagrams. They are vital tools that allow us to visualize the ancient supercontinent. It's recorded in geological structures, fossils, and even climate data, reminding us of the volatility and incredible power of our planet. But how do we even know Pangea existed? It's not just a nice theory. Its existence is supported by a whole arsenal of compelling evidence, collected by scientists like detectives investigating a case hundreds of millions of years old. The first and most obvious clue is geology. When we look at a world map, the outlines of continents, for example, the east coast of South America and the west coast of Africa, align almost perfectly, like pieces of a torn map. But the similarities go much deeper. Scientists studying rocks around the world have discovered that entire mountain ranges, today separated by thousands of kilometers of ocean, have identical composition and age. For example, The Appalachian Mountains in North America are geologically a continuation of the Caledonian Mountains in Scotland. The only explanation is that they were once a single mountain range that ran through the center of Pangea. The second piece of evidence, perhaps the most compelling, is fossils. Paleontologists find the remains of the same ancient animal species on continents that are now separated by insurmountable water barriers. A classic example is Mesosaurus, a small freshwater reptile. Its fossils are found in only two places on the planet, South America and South Africa. It was a tiny creature that physically could not have crossed the Atlantic Ocean. By studying the Earth's structure in detail, these maps reveal the composition of rock layers and all the changes accumulated over millions of years. The arrangement of rocks of different types and ages allows scientists to compare geological features across different, now distant continents. By studying these characteristics, they piece together fragments of the past, like a giant jigsaw puzzle, revealing how the continents were connected before they were torn apart by the inexorable forces of nature. One of the most striking discoveries to be made when looking at these maps is the striking similarity of geological features across the planet. For example, if we look at the east coast of South America and the west coast of Africa, we see almost mirror images. The geological formations, ancient mountain ranges, and even the fossils found there all match. This data is irrefutable evidence that these continents were once a single entity. Maps showing the remains of ancient continents depict a single, continuous history of the Earth, stretching back hundreds of millions of years. Modern geologists, armed with cutting-edge technology, use this data to create 3D models of the Earth's crust. These models allow us to see how continental plates have drifted over time, revealing the long and dramatic journey that led to the current arrangement of the continents. These studies help us better understand the dynamic living nature of our planet. They show how lands once covered in dense forests or pierced by towering mountain ranges can now be barren plains. Mountains crumbled, fractured, and shifted to ultimately form the continents we know today. By analyzing geological and paleontological data, scientists can literally resurrect ancient ecosystems. During the heyday of Pangea, we find traces of the same ancient life, such as dinosaurs, on completely different continents. This is confirmed by the location of geological formations on modern maps. These maps are more than just surface images. They are a true window into the distant past, allowing us to marvel at the majesty of continental drift and the complex web of life that emerged in this ever-changing world. Studying Pangea, a supercontinent that existed approximately 300 million years ago, offers us a fascinating glimpse into Earth's geological history. It offers scientists a fascinating panorama of tectonic plate movements over entire eons. This knowledge is crucial as it helps us understand how continents shift and change shape, vividly demonstrating the ever-turbulent nature of the Earth's surface. By studying how Pangea split apart, scientists are gaining a deeper understanding of the principles of plate tectonics. The slow but inexorable movement of these giants creates new geological features while simultaneously destroying old ones. For example, the Great Rift of Pangea led to the creation of entire ocean basins and the formation of the mountain ranges we see today. By studying these processes, researchers can make more accurate predictions about how the planet's geography will change in the future. The geological evidence left by Pangea, such as the distribution of fossils and mineral deposits, provides us with invaluable information about past climates and ecosystems. This historical context also helps us understand current changes. We can visualize how continents formed, drifted, and changed their shape. This knowledge will help scientists better predict the potential consequences of modern geological activity, such as earthquakes and volcanic eruptions. Pangea also offers important lessons about climate change. It demonstrates how closely interconnected Earth's different regions are. When continents collide or break apart, it dramatically alters ocean currents and atmospheric flows. This knowledge helps us monitor current geological activity and predict future changes. Thus, Pangea is not just a fascinating chapter in our planet's history, but also a crucial tool for predicting its distant future. This history, which began millions of years ago, is a striking example of the complex tectonic processes occurring on our planet. Studying the Pangea plates allows us to better understand how they move, interact, and how they may change over time. After all, the great breakup of Pangea, which began about 200 million years ago, is in fact ongoing to this day. The surface of our planet is not solid rock, but a living, breathing stage where the eternal drama of creation and destruction unfolds. Let's travel back hundreds of millions of years to a time when a single supercontinent reigned supreme on Earth. But this gigantic landmass, the progenitor of all modern continents, was not a motionless block. No, it was alive, in constant if invisible motion. Pushed by the colossal forces raging within the planet's molten core, it drifted across the molten mantle. It is this inexorable process known as plate tectonics that has carved and reshaped the face of the Earth over the eons. The continents we see on maps today are merely fragments of that ancient world, the result of a great rift. This titanic drift completely changed the rules of the game for all life. It reshaped ecosystems, reversed ocean currents, and forever altered the planet's climate. Looking into the stone record of those times, we find irrefutable evidence of great extinctions and monumental transformations. And all of this was directly linked to the movement of continents. It's important to understand the dance of tectonic plates is not just a fact from a geology textbook. It's an ongoing process that continues to shape the future of the planet before our very eyes. Let's take a look into this future. Scientists are confident tectonic plates show no sign of stopping. Vast land masses will continue their slow but inexorable journey. Some will drift apart, expanding the oceans between them, while others, conversely, will converge, preparing for a titanic collision in tens of millions of years. We can already observe this with our own eyes. The Atlantic Ocean is growing wider every year, mercilessly pushing America, Europe, and Africa apart. At the same time, we are witnessing the consequences of another collision. The slow but devastating ramming of the Indian subcontinent into the Eurasian plate, literally upheaval of the Earth's crust, giving birth to the highest mountains on the planet, the Himalayas. All these monumental shifts serve as a powerful reminder that the Earth beneath our feet is a living, constantly changing organism. And ultimately, these shifts could lead to the birth of a new supercontinent. This is a cyclical phenomenon that repeats with alarming regularity, approximately every 400–600 million years. Some geologists have already given this future giant a name, Pangea Proxima. Understanding how ancient Pangea existed and disintegrated gives us the key not only to our planet's past, but also to its distant future. It forces us to take a completely different look at long-term environmental challenges and recognize the true power of these slow but all-consuming geological forces. The story of Pangea, like nothing else, makes us feel how fleeting human existence is against the backdrop of Earth's eternal evolution. When we peer into this distant future, a picture emerges that is strikingly reminiscent of the world of the ancient supercontinent Pangea. This incredible prospect is not a figment of imagination, but a logical result of the incessant movement of tectonic plates, those gigantic fragments of the Earth's crust that tirelessly glide across the surface of the molten mantle. Right now, at this very second, they are moving. Their speed is negligible, a few centimeters per year, slower than human fingernails grow. These changes are completely imperceptible on the scale of a single human lifetime. But if we look at this process over millions of years, the picture becomes truly grandiose. These centimeters add up to thousands of kilometers, leading to colossal geographical reorganizations. According to some predictions, in approximately 200 million years, the continents may once again converge at a single point, driven by the inexorable dynamics of the planet's interior. There are hypotheses that the Atlantic Ocean, which is currently expanding, will begin to contract in the future, bringing the Americas closer to Europe and Africa once again. Such a merger of the continents will inevitably lead to the birth of a new supercontinent, very similar to Pangea, with vast interior territories transformed into arid deserts and entirely new ecosystems born from radical changes in ocean currents. What's most interesting is that the shape of the new Earth won't be shaped solely by tectonics. Other powerful forces will also come into play. Global climate change, fluctuating sea levels, and even violent volcanic activity. As the climate shifts, some regions will become more habitable, while others will become lifeless wastelands. Over geological timescales, entire swathes of land could rise from the sea, or conversely, sink beneath the waves. This complex harmony of geological and climatic forces suggests that not only the physical arrangement of the continents will change, entire ecological communities will also undergo profound transformations. Perhaps some life forms will be able to adapt to these incredible changes. Therefore, the idea that our future Earth could become a mirror image of the ancient world of Pangea seems both exciting and frighteningly plausible. By studying these geological metamorphoses, we are only beginning to understand just how dynamic our planet is. This eternal interplay of time and nature continues to shape the world as we know it. What lies ahead remains the greatest mystery. The ancient supercontinent Pangea, which existed approximately 300 million years ago, provides us with invaluable clues about what the world of the future might be like. The lessons we learn from its history reveal the dramatic consequences of climate change on the Earth's ecosystems and geology. In those distant times, Pangea united a wide variety of climate zones and habitats on a single, gigantic landmass. This colossal unity of land directly influenced atmospheric flows and the distribution of plants and animals across the planet. This state of affairs had serious consequences, including dramatic climate shifts and biodiversity loss, serving as a stark reminder of how closely all of our planet systems are interconnected. As Pangea began to fracture, insurmountable geographic barriers began to form. Oceans separated once united populations, and on these isolated worlds, evolution took its own unique paths. The very fact that one giant continent has fragmented into many smaller ones, each experiencing vastly different climates, from parched deserts to tropical rainforest, is a clear example of how geography can influence the diversity of life. And these ancient patterns are frighteningly relevant today, as anthropogenic climate change threatens the survival of countless species worldwide. The consequences of these changes remind us of the delicate balance that exists in nature. The formation and subsequent breakup of Pangea dramatically altered ocean currents and global weather systems. This is a striking demonstration of how interconnected climate processes are on the planet. A disruption in one part of this complex system can trigger a chain reaction across the globe, highlighting the urgent need for a comprehensive approach to addressing today's climate challenges. Finally, the lessons learned from Pangea's history speak to its incredible resilience and adaptability. Species successfully adapted to changing conditions both during the supercontinent's existence and after its breakup. And we, as a species, must evolve to withstand current challenges. By learning from the past, we can better prepare for the future. The history of Pangea serves as a crucial guide for us in these challenging times. The very concept of a future supercontinent excites scientists, opening up intriguing possibilities. As tectonic plates continue their slow movement, the possibilities for preserving Earth's biodiversity are changing. The gradual merger of continents has the potential to completely reshape habitats and ecosystems on a global scale. This dramatic geological change could create incredible opportunities for some species and deadly threats for others. When continents merge, they could form vast, previously unseen landmasses. This new environment could foster the emergence of unique and exotic habitats. These vast landmasses could become home to diverse flora and fauna, which in turn could lead to an explosion of biodiversity. Newly formed ecosystems could provide new species with a chance to thrive, and evolutionary processes could lead to the emergence of striking adaptations. However, for neighboring regions that find themselves squeezed into the supercontinent, the consequences could be catastrophic. The convergence of previously isolated ecosystems poses a mortal threat to existing species, as competition for resources will intensify to the extreme. Only the strongest will survive. On the other hand, the creation of a supercontinent could lead to horrific habitat fragmentation. As species struggle to adapt to the changing landscape, those unable to migrate or adapt to the new conditions will inevitably face extinction. Any changes in climate or geography can also disrupt centuries-old connections between species, for example, by disrupting animal migration routes. This could lead to a sharp decline in populations if creatures are unable to find new routes in this changed world. Thus, the birth of a supercontinent could have both positive and extremely negative consequences for life on Earth. On the one hand, it offers the chance to create new worlds and trigger an incredible evolutionary cycle. On the other hand, it could disrupt the delicate balance of existing ecosystems and lead to mass extinctions. The conclusion is obvious. In Mesosaurus's time, there was simply no Atlantic Ocean between these lands. They were connected, and the small reptile moved freely along the rivers and lakes that flowed across the same landmass. The third clue is hidden in the Earth's climate archives. We find enormous deposits of coal, which forms from the remains of swamp vegetation in hot and humid climates in regions that are now cold, such as North America and even Antarctica. This clearly indicates that these lands were once much closer to the equator. Conversely, traces of ancient glaciers, scars left by giant ice sheets, are found in tropical regions of Africa and India. This climatic madness can only be explained in one way. All these lands were part of a single continent that slowly drifted across the planet, crossing different climate zones. All these threads, geological coincidences, fossil evidence, and climatic paradoxes, weave together to form a single, irrefutable picture of the distant past. They paint before us the image of a world with a single supercontinent, a world that is difficult for us to even imagine today. Let's take another look beneath the surface to understand how this planetary mechanism works. Earth's outer shell, the lithosphere, consisting of the crust and the upper solid mantle, is broken into tectonic plates. These plates, like ice flows on water, drift over a more flexible, semi-liquid layer beneath them. As scientists continue to study these scenarios, we gain invaluable information not only about the past, but also about the future of life on our planet. Studying the ancient world of Pangea is like peering through a window into not only Earth's dynamic geological history, but also, perhaps, its future. During Pangea, we can see how titanic tectonic processes sculpted the planet's surface, creating unprecedented ecosystems and opening new paths for evolution. During those eras, the planet experienced monumental geological cataclysms, including massive volcanic eruptions, capable of changing the climate, and powerful earthquakes that shook entire continents. Let's travel back in time to an era of titanic cataclysms that forever changed the face of the Earth. We are talking about natural disasters of incredible power generated by an invisible yet all-powerful process, the movement of tectonic plates. These gigantic slabs of the Earth's crust, slowly but inexorably moving, eventually tore apart the great supercontinent of Pangea. It was clear and brutal proof that the surface of our planet is not a static rock, but a living, breathing, constantly changing system. And as we peer into the uncertain future, we can see disturbing echoes of those ancient cycles of movement and destruction we witnessed in the history of Pangea. Today, as they did millions of years ago, tectonic plates continue their slow but inexorable march. This movement, like a coiled spring, accumulates monstrous tension in the Earth's crust over centuries. And then in an instant, this energy is released, generating earthquakes that shake entire continents, just like the geological catastrophes of the distant past. It is safe to say that as the continents continue to drift, some corners of our world will become epicenters of violent seismic activity and fiery volcanic breath. And that's not all. Consider the global climate shifts, which are eerily reminiscent of the environmental upheavals that raged during the existence of Pangea, that ancient supercontinent, with its gigantic landmass, dramatically altered ocean currents and airflow patterns. This, in turn, transformed the climate into a veritable seesaw. Dry periods alternated with periods of monstrous storms. Today, as our planet succumbs to global fever, we are already witnessing similar shifts in weather. These changes, like a ghost of the past, could lead to even more frequent and devastating natural disasters, such as deadly hurricanes and devastating floods. The story of Pangea is more than just a page from a geology textbook. It's a stark reminder of the colossal forces that shape our world, and at the same time, a cautionary tale for us, the inhabitants of Earth today. A look into the planet's geological future makes it clear. Natural disasters are not random tragedies, but an integral, fundamental part of the eternal process of transforming our home. And as we try to find our place in this complex and ever-changing world, we vitally need to understand this ancient, inextricable connection between geology and climate, and most importantly, our own role in this great and dangerous interplay. Pangea, this single landmass that existed approximately 300 million years ago, is our greatest key to understanding the past of Earth and its living systems. Imagine, almost all of the planet's landmass was gathered into a single gigantic continent, creating a unique, unparalleled arena for life. Studying this world helps us understand how geological storms and climate fluctuations affect all life, even biodiversity. And this knowledge is more important today than ever as we face similar challenges, only this time caused by our own actions. Seeing how ancient species adapted to the harsh conditions of Pangea provides invaluable lessons for developing strategies to save our own world. For example, paleontologists can literally trace bone by bone the migration and evolutionary paths of ancient creatures as the continents drifted apart. These ancient records reveal how entire ecosystems could adapt to dramatic changes or, conversely, collapse under their weight. And as we face modern threats like climate change and habitat destruction, we can draw wisdom from the incredible resilience of ancient creatures. This helps us develop more effective conservation measures. The study of Pangea also demonstrates the enormous importance of protecting fragile ecosystems in our changing world. It shows that all life on the planet is connected by invisible threads. When we look to the past and see how billions of organisms coexisted and thrived on a single gigantic continent, we recognize a fundamental principle. The health of one ecosystem directly impacts the well-being of all others. A blow dealt in one corner of the world echoes across the entire living fabric of the planet. This glimpse into the past inspires us to take a more holistic approach to conservation, forcing us to see not just individual species, but the complex web of life. Protecting one forest or one animal species in isolation is no longer enough. The lessons learned from the history of Pangea help ecologists and conservationists better address the challenges of our time. Every fossil in a museum display case is a reminder of how dynamic our planet is and how fragile its greatest treasure, biodiversity, is. Events similar to those that once split Pangea will have enormous consequences for the future climate, ecosystems, and perhaps even the very survival of humanity. The formation of a new supercontinent is a process driven by the inexorable force of tectonic plates, and although it may take millions of years, its effects will be felt across the entire planet. One of the first and most dramatic effects will be a radical change in the global climate. As the continents merge, their interiors, cut off from the influence of the oceans, will turn into vast, sun-baked deserts, similar to today's Sahara or Gobi Desert, but on a much larger scale. On the other hand, coastal areas of this new world could experience a milder and more moderate climate, under the moderating influence of vast oceans. The new arrangement of land and sea will also completely redraw the map of ocean currents, which play a key role in distributing heat across the planet. This shift could lead to completely unpredictable weather anomalies, devastating agriculture and ecosystems worldwide. The planet's living systems will also be subjected to the most severe tests. The merging of continents will lead to the mass extinction of some species whose habitats will be simply wiped off the face of the Earth. Meanwhile, other, more adaptable species will be able to survive and even thrive in the new, changed conditions. This will lead to a great mixing of species from different continents. Imagine, predators and prey that have never met will find themselves in the same arena. Some will thrive, while others will desperately struggle to survive in this new, harsh world. The biodiversity of our planet will change beyond recognition. Human civilization, if it survives until then, will also face challenges of biblical proportions. The new supercontinent will completely alter migration patterns, resource distribution, and the entire geopolitical landscape. Nations separated today by vast oceans will once again find themselves neighbors. This will likely facilitate incredible cultural exchange. However, conflicts over resources, water, fertile land, life itself, will undoubtedly transform humanity, serving as a brutal reminder of our fragility in the face of geological forces. In the ongoing, gripping drama of Earth's geological history, the very idea of Pangea, a vast supercontinent that existed some 300 million years ago, fundamentally changes our understanding of the world. We're accustomed to thinking of continents as stable, eternal entities, but the story of Pangea shatters this illusion, revealing a far more dynamic and violent picture. It tells us that the continents we see on the map today were once merely fragments of a single, colossal structure. Continental drift is a key element of the theory of plate tectonics. This theory posits that the Earth's solid crust is divided into giant plates that float like ice floes on a semi-liquid hot mantle. Over millions of years, currents in the mantle have moved and pushed these plates together like giant billiard balls, leading to the birth and death of continents. This endless process proves that our continents are not static, but are in a state of perpetual motion. Fossil finds provide irrefutable evidence. They confirm that ancient species were once widespread across Pangea. Today, their remains are found in isolated regions on different continents, directly indicating that these land masses were once connected. For example, fossils of the ancient reptile Mosasaurus have been discovered in both South America and Africa, providing compelling evidence that these continents were once a single entity. These finds are voices from the deep past, telling us the story of continental movement and shattering old notions of immobility. The story of Pangea thus forces us to completely rethink Earth's geological chronology. It paints a picture of a planet full of violent change and transformation, a picture of a dynamic past that continues to shape the world we inhabit to this day. A modern understanding of continental drift can significantly expand our understanding of the fate of the Earth. It shows that the landscape we see outside our window is just one frame in an endless geological saga. By observing the slow but inexorable movement of the continents, we can imagine several scenarios that could radically alter our planet in the distant future. Current evidence shows that the continents are slowly but surely shifting under the titanic forces of tectonic plates. Over millions of years, this movement could lead to the birth of new mountain ranges, the formation of vast ocean basins, and possibly the merging of entire land masses. For example, if current trajectories continue, our distant descendants could witness the gradual collision of Africa and Europe. This colossal geological event could give birth to a new mountain range rivaling the Himalayas in grandeur. However, it would also have a profound impact on weather patterns and biodiversity in the region, creating new ecosystems and threatening existing ones. At the same time, the continents of North and South America continue to drift away from Europe and Africa. This slow divergence will cause the Atlantic Ocean to widen even further, turning into a vast aquatic desert, separating the worlds. Imagine a planet in the distant future. Slowly but inexorably, the tectonic plates continue their great journey. The Atlantic Ocean, that gigantic expanse of water, will only expand, pushing the continents further and further apart. This isn't just a change on the map, it's a complete restructuring of climate systems. Ocean currents, those invisible rivers that carry warmth and life, will shift their routes. The consequences for marine life will be catastrophic. Entire ecosystems will be threatened, and fish populations as we know them will face the greatest challenge in their history. But this is only one part of the great geological cycle. Let's look even further ahead, hundreds of millions of years into the future. Scientists hypothesize a monumental event, the birth of a new supercontinent. In this distant future, the continents, tired of their solitary voyages, will come together once again to merge into a single, colossal landmass. This future giant has already been given a name, Pangea Proxima. Its emergence will forever change the face of our planet, creating a world we can hardly imagine. The history of global geography unfolds before us, its invisible yet constant influence on all life. This slow, majestic dance of the continents serves as a constant reminder that our planet is a dynamic, living system. It is in perpetual motion, transforming our world in ways that are sometimes difficult to even imagine. And when we speak of such titanic processes, it's impossible not to turn to the past, to the image of that very same primordial Pangea. This is not just a geological term. For us humans, the very idea of a single continent, once a common home for all life, carries a profound, almost philosophical meaning. It is a powerful reminder of unity. The thought that we all, despite our current differences, come from the same world, from a single shared patch of land, makes us reflect on our roots, on what binds us all together. As we study this great schism, we inevitably draw parallels with our own history. We see how the physical separation of continents is reflected in the barriers we erect between ourselves. Pangea teaches us a poignant lesson. The Earth was once united, and perhaps this natural state holds the key to understanding how we can live on it today. This inspires us to rethink our approach to global challenges and strive for cooperation, understanding, and empathy among different peoples. A logical question arises. If we were once all part of a single Earth, shouldn't we strive for a common future? The very image of Pangea grows from geology and becomes a powerful metaphor for life. It speaks to ecology, to the fragile web of interconnections that permeates the entire planet. Just as the splitting of the continents gave rise to unique, isolated ecosystems, so the division of humanity has led to the emergence of an incredible diversity of cultures and worldviews. But knowledge of our common roots can become the foundation that unites this diversity. Our responsibility to each other and to the planet itself is a direct reflection of our profound interconnectedness. This idea compels us to think globally and act in ways that benefit everyone, bringing the concept of one Earth to life. Thus, Pangea is more than just a chapter in a geology textbook. It is a philosophical perspective on the very essence of our existence. Understanding that our origins lie in a single spot on the map of the ancient world helps us to deeply appreciate the importance of solidarity in the face of modern challenges. From global climate change to cultural contradictions, this ancient knowledge guides us toward a future in which we recognize our shared heritage and our common destiny. The era of Pangea, a time when all the continents were bound together into a single titanic landmass, offers us a unique opportunity to take a fresh look at our planet's past and present. And they are driven by the indefatigable force of mantle convection. Imagine a giant cauldron boiling deep within the Earth. Hot matter rises from the bottom to the surface. There it cools, becomes denser, and sinks again, giving way to new hot currents. This endless cycle creates powerful currents that drag the lithospheric plates floating on the surface. For millions of years, these currents inexorably drew disparate land masses closer together. The oceans separating them collapsed and disappeared, and continents collided, leaving scars in the form of mountain ranges. By the end of the Paleozoic era, virtually all the planet's landmass was gathered into a single, colossal landmass, Pangea. This event created completely unique conditions for life, with vast inland deserts and diverse coastal zones. But then, about 200 million years ago, the pendulum swung back. Convection currents reversed direction, and the forces that had held Pangea together for so long began to tear it apart. The continent cracked, and magma gushed into the fissures, giving birth to new oceans. Thus began the formation of the world we know today. This legacy of tectonic movements, this eternal dynamism of the Earth, determined the entire subsequent geological and biological history of our planet, revealing just how vibrant and changeable the world beneath our feet is. And one of the personal discoveries that awaits each of us is the realization of how temporary everything around us is. Pangea existed for millions of years, but even it was not eternal. Eventually, powerful forces tore it apart. This is a great lesson from nature. change is not an accident, but a fundamental law of the universe operating both on a planetary scale and in the lives of each of us. Understanding this helps us accept the inevitability of change in our own world. We are beginning to understand that, like the continents on which we stand, everything around us is in constant motion and transformation. Another striking aspect of studying Pangea is the profound sense of interconnectedness that reigned during that era. Imagine, a wide variety of organisms shared a common space, inhabiting unified ecosystems which, millions of years later, would be separated by thousands of kilometers of ocean. This serves as a powerful metaphor for our own need for connection. In our world, which seems increasingly divided, the idea that the ancestors of all living things once roamed the same earth can inspire us to search for what unites us. It pushes us toward global cooperation and understanding, despite all apparent differences. Moreover, reflecting on Pangea deepens our understanding of how the Earth itself creates biodiversity. As the continents drifted apart, unique, isolated worlds formed within them. This led to an evolutionary explosion that gave birth to countless new species. And today, looking at this astonishing diversity of life, we cannot help but consider our role in preserving it. We begin to recognize how our actions impact the delicate balance of life on Earth. The story of Pangea is a saga of unity and the subsequent Great Division. But the era of Pangea forces us to look not only to the past, but also to the future. Just as tectonic plates slowly but surely moved back then, creating new landscapes and changing the face of the planet, they continue to move today. This serves as a stark reminder that our actions today can have colossal consequences for generations to come. By studying Pangea, we don't just learn a history lesson. We reflect on our responsibility for this world. Human curiosity about Pangea, the legendary supercontinent that existed some 300 million years ago, embodies our deepest desire to understand the history of the planet and our most distant ancestors. With its vast expanses and diverse ecosystems, it symbolizes a time when all life was concentrated on a single continent. This inextricable connection with Earth's deep history inspires us to explore not only the geological mysteries of our world, but also to seek out potential oases of life beyond it. And so, looking at these titanic slabs that once sculpted the face of Pangea, we understand our Earth is a living, breathing organism that never stands still. And this knowledge ignites a spark of curiosity within us, pushing us to look beyond our own world. We begin to explore other planets, wondering, what secrets do they hold? Can we find traces of ancient landscapes on Mars similar to those that existed on early Earth? Perhaps dried up riverbeds on its surface or the enigmatic features of Venus's topography will tell us the story of a world where life once teemed. Each new exploration mission brings us closer to answers that could shed light on the mysteries of our own evolution. Moreover, interest in Pangea resonates with the eternal question of the habitability of other worlds. If an ancient supercontinent could support such diverse life forms, why wouldn't we find traces of them elsewhere in the solar system? This prospect excites the imagination. The hypothesis of microscopic life in the subglacial oceans of moons like Europa, or even in the clouds of Venus, no longer seems like science fiction. Each new mission, whether to Mars or beyond our solar system, pushes the boundaries of knowledge and reflects our eternal quest to understand whether we are alone in the universe. Ultimately, curiosity is the driving force behind all our discoveries. Knowledge of Pangea not only reveals our own evolutionary path, but also strengthens our desire to explore new worlds. Studying the historical context of Pangea helps develop a holistic view of environmental protection and the importance of preserving our planet as a whole. Pangea also awakens our spirit of exploration and discovery, painting a picture of a world where all the continents were once connected. It sparks curiosity about ancient life forms and lost biodiversity. Creatures flourished in those times, the secrets of which are now hidden in deep layers of rock and the fossil record. This enthusiasm, this desire to peer into the past, is especially important for younger generations who are taking responsibility for the future of the planet. This is the true value of scientific inquiry. Each new discovery, each fossil found, is more than just an isolated fact. It is another thread woven into the grand tapestry of our planet's past, allowing us to more deeply understand not only where we came from, but also where we are heading. In this sense, Pangea is more than just an ancient continent. It becomes a metaphor for the unity of all humanity. Consider for a moment, there was a time when the entire landmass on which our cities and countries now stand was a single, monolithic massif. This idea of a past unity can be a powerful inspiration for us today. It reminds us that working together for great goals can lead to incredible breakthroughs in science and global understanding. Awareness of our shared profound history on this planet can inspire us to collective action in the face of global threats. It creates the very atmosphere in which curiosity and a thirst for knowledge flourish. And may the ghost of Pangea become a guiding light for future generations of scientists and explorers, illuminating their path to new discoveries and helping them unravel the greatest mysteries of our world, reminding them of our common origin and shared destiny. Let's travel back in time 300 million years to the story of Pangea. This ancient supercontinent, which united all of Earth's landmass, is key to understanding not only geology, but also the very meaning of our existence. Its history, unfolding eons before the first humans, forces us to ask eternal questions about our role in the vast universe. As we watch this colossal landmass slowly but inexorably begin to fragment, we receive a powerful lesson in the impermanence of all things. It's a reminder of what it's like to live on a planet in perpetual motion and transformation. The ceaseless dance of lithospheric plates beneath our feet is a silent testimony that nothing lasts forever. Even the most stable and immutable landscapes in our view can be erased from the face of the earth by the inexorable march of time. The very idea of Pangea's existence evokes profound reflections on the interconnectedness of all life. Imagine a time when all life on the planet was concentrated on a single, gigantic continent, albeit separated by internal barriers. The astonishing diversity of species evolving in isolation from one another gave rise to unique evolutionary paths, opening before us an incredible historical panorama. It forces us to consider the value of connections in our own lives. Are our destinies, our personalities, like those ancient continents, destined to forever drift apart? Or are we, unlike stone, capable of finding ways to bridge any chasm? Moreover, the story of Pangea's slow disintegration is a grand saga of resilience and vitality in the face of colossal change. Life did not perish. It adapted to the new, sometimes brutal conditions that emerged from this planetary rift. It demonstrated an incredible ability not just to survive, but to thrive in a changed world. And this forces us to examine ourselves. Humanity constantly faces upheaval, be it climate change, social upheaval, or dizzying technological advances. Can we learn lessons from our planet's ancient history? Can we learn from Earth's own resilience to make our own societies more resilient? Finally, the saga of Pangea prompts us to view time and legacy from a completely different geological perspective. As we reflect on our tiny place on this grand timeline, the story of Pangea becomes a poignant reminder of our fragility, but also of our hidden power in this majestic and interconnected web of life. Pangea, this ancient supercontinent that existed approximately 300 million years ago, serves today as a powerful symbol of unity and global cooperation. Just think, there was a time when all the land on Earth was one, embodying a world where differences were not barriers but merely parts of something greater. Those distant eras, when the continents functioned as a single organism, can serve as inspiration for our efforts today. Look at Pangea. We can imagine how closely its vast territories were connected by shared ecosystems, a common climate, and shared resources. This interdependence created unique conditions for the flourishing of diverse life forms. Just as today, by uniting, humanity can solve global problems, be it climate change, pandemics, or poverty. Pangea is a perpetual reminder of how closely we are all connected in the modern world. It underscores a simple truth. Together, we can find solutions that benefit all of humanity, not just individual countries or groups. On the other hand, the disintegration of Pangea itself serves as a dire warning of the dangers of separation. As the continents drifted further and further apart, they became increasingly isolated and alone. This isolation not only gave rise to unique regional differences, but also created barriers that hinder cooperation in our modern world. The separation of peoples and cultures can lead to misunderstanding, conflict, and slow overall progress. However, if we remember our common roots, that we all hail from the same landscape of ancient Pangea, this can become the foundation for collaboration. This will help us overcome gaps and rekindle the spirit of cooperation. By understanding the essence of Pangea, we can imagine a future where all global endeavors are built on unity, mutual respect, and understanding. This reflects our belief that despite all our differences, we can achieve much more if we unite around shared goals. Thus, Pangea is more than just a chapter in a geology textbook. It remains a living and compelling metaphor, reflecting the incredible potential of our global community. The idea of Pangea, this supercontinent from the distant past, forces us to rethink the development of human society. The connection between Earth's geological history and the trajectory of our civilization challenges our understanding of the world and demands new discoveries and fresh approaches to old problems. Our sense of superiority over nature can be a dangerous delusion. The planet's history is a reminder that it has endured trials we can only imagine. Long before the first humans walked the earth, titanic forces fused together the vast land masses we now know as continents. This proves that ecosystems can thrive in the most unimaginable conditions, and the world we see today is but a fleeting moment in the planet's long history. For millions of years, the Earth's surface has been continually reshaped by tectonic forces raging deep beneath our feet. The final disintegration of Pangea highlights not only nature's incredible capacity for self-transformation, it also reveals how short humanity's existence is on a geological scale. The story of Pangea puts us in our place, reminding us that we are but a tiny part of a far greater historical process. Moreover, Pangea's biological legacy reveals another fascinating aspect of nature's superiority over human control. On this single landmass, diverse species intermingled and collided, triggering remarkable evolutionary processes and creating incredible biodiversity. While our cities and civilizations can arise and disappear in the blink of an eye on the geological clock, these deep biological connections, formed over millions of years, can flourish or collapse completely independently of our efforts. Ultimately, the story of Pangea is a powerful lesson in humility. It underscores that we are but a small part of the ever-changing face of the Earth. Despite all our technological advances, we remain at the mercy of natural forces far beyond our understanding and control. And this fact should resonate loudly in all our current debates about environmental protection and sustainable development. Reflecting on Pangea reminds us of our shared past. We remind ourselves of the need to respect nature and strive to live in harmony with it. This discovery was a true breakthrough not only in our understanding of geography, but also in how we understand the great migrations of ancient species and even the use of resources by our distant ancestors. In the world of science, the theory of a single supercontinent, Pangea, formed the basis for the study of plate tectonics. It is this theory that has finally allowed scientists to explain the monumental movements of the continents and the geological mysteries we see around the globe today. This new understanding, in turn, led to crucial discoveries about the nature of earthquakes, the ferocity of volcanic activity, and the slow but inexorable birth of gigantic mountain ranges. All of this became irrefutable proof that our planet is a living, breathing, and constantly changing organism. Scientists began to understand the incredible speed with which, in geological terms, the face of the Earth was changing, and this forever changed our understanding of its turbulent history. The story of Pangea is a striking example of how human imagination, fueled by scientific inquiry, can inspire entire generations to explore and conquer the unknown. Our thirst for knowledge has not only expanded our geographical horizons, it has allowed us to peer into our planet's deepest past. And it is the past, as we know, that determines our future. Let's fast forward 300 million years. After all, it was here long before us and will remain here long after we are gone. Pangea, a supercontinent that existed approximately 300 million years ago, offers us a unique glimpse into how our world formed and human cultures evolved. When Pangea broke apart, it laid the foundation for the modern planet, with its astonishing diversity of geographic and cultural landscapes. The traces of this ancient landmass are more than just geological markers. They are a reminder of our shared history. The geological origins of Pangea prove that all continents were once a single entity, testifying to a deep, primordial kinship between us all. Among land masses we today consider separate and distant, this ancient connection has the potential to transform our understanding of ourselves. She emphasizes that the boundaries that divide us today, whether oceans or political lines on a map, are relative and very recent. For example, consider the mountain ranges and rock formations across continents. Their striking similarities reveal how the Earth's very structure once united different regions long before they gave rise to distinct cultures. Culturally, the idea of Pangea challenges us to consider how human societies evolved in a changing world. When ancient tribes migrated across lands we now call distinct continents, they carried with them not only their genes, but also their languages, traditions, and customs. These echoes of ancient connections remind us that cultural exchange was the norm, not the exception. It influenced all aspects of life, from art and mythology to agricultural practices. This grand historical panorama challenges modern notions of cultural isolation, proving that we are all branches of a single mighty tree whose roots reach back to the single land of ancient Pangea. We often forget that our world wasn't always divided by oceans and continents. There was an era when all land was one. That world was called Pangea. And this isn't just a geological fact, it's the key to understanding our deep, primordial unity. By peering into this hazy past, we begin to see the big picture. We realize that regardless of our modern borders, nationalities, or cultures, we all share a common heritage, carved in the stone of the planet itself. The idea of Pangea forces us to look at ourselves in a new way. It reminds us that when giant tectonic plates began their slow dance, pulling the continents apart, each of us took with us a piece of that shared, primordial world. And this piece still shapes how we interact with each other and how we perceive this planet. Let's cast our thoughts back 300 million years. An ancient supercontinent stretches before us, and the sight evokes a storm of emotions. On the one hand, there's awe at nature's grand design, merging all the continents into a single landmass. On the other, there's a quiet sadness, knowing that this unity has come to an end. This vast, interconnected world is living proof of how dynamic and changeable our Earth is. Powerful geological forces shaped its face, and the idea that the familiar continental contours we know were once part of this colossal whole awakens a burning curiosity. We want to know how our planet changed and what titanic processes continue to shape it today. There's something poignant, almost personal, about this schism. When this magnificent unified land began to crack at the seams and disintegrate into lonely island continents, it resonates with each of us. This story resonates with our own experiences of loss, separation, and change. The splitting of the continents was a death sentence for countless species. Ecosystems that had existed for millions of years collapsed overnight, and the course of life on the planet itself was forever altered. This chapter in the story of Pangea is a stark reminder of the fragility of all life and the inevitability of change that time brings. At the same time, the story of Pangea gives us an incredible sense of universal connection. Today, When continents are separated by thousands of kilometers of water and cultures developed in isolation, this ancient memory of unity becomes a powerful symbol. The realization that the land beneath our feet was once part of a single gigantic continent inspires us to rise above geographic and political barriers. It is a powerful metaphor for global unity, telling us that despite all our differences, we share a common origin that deserves the deepest respect. The story of Pangea evokes a spectrum of emotions within us, from sacred awe to radiant nostalgia. It fills us with a sense of the preciousness of our planet's complex history. Reflecting on this ancient world and the titanic forces that created it, we understand that we are an integral part of this great legacy. This reminds us that both nature and humanity are in perpetual motion, weaving together a rich and unique tapestry of life. This connection between time helps us peer into Earth's distant past, as if through a window, and see the complex history that still shapes our present and determines our future. By delving into the planet's geological record, studying fossils and ancient climates, we begin to understand the dynamic forces that have shaped the Earth over millions of years. This knowledge allows us to discern patterns, predict future changes, and gain a deeper understanding of how life originated, evolved, and adapted throughout history. Take, for example, ice cores extracted from the deepest reaches of Antarctica. Each layer is a frozen page of history, revealing the composition of the ancient atmosphere. These icy archives reveal how carbon dioxide levels changed, directly influencing climate and the evolution of life. We see that the climate has always changed, following natural cycles. By comparing ancient periods with high atmospheric carbon levels to today's levels, scientists can more accurately predict the consequences of our own actions. We gain a clearer understanding of how our planet's ecosystems function. How life responded to climate change in the past gives us invaluable clues about how to address similar challenges today. Remembering the great extinctions of the past, such as the extinction of the dinosaurs, serves as a stark warning. It screams at us about the fragility of life on Earth. These catastrophes were often triggered by abrupt climate shifts and the destruction of familiar habitats, and were sometimes exacerbated by external impacts, such as giant asteroid strikes. By studying these tragic events, we begin to truly appreciate biodiversity and the complex interconnectedness of all species. This motivates us to act to protect the fragile ecosystems of today. Lessons from the past are not just dry facts from textbooks. They are the key to understanding our future. To ensure that future, we must remember how events of the distant past can echo and influence the climate and life today. This knowledge helps us make informed decisions that will preserve our planet for generations to come. And this deep connection with the past awakens in us a sense of responsibility, forcing us to care for the Earth as our only home. Now let's imagine Pangea as a gigantic stage for the most incredible stories. This world that existed 300 million years ago offers a captivating backdrop for narratives brimming with drama and adventure. In this world, colossal mountain ranges pierce the clouds, endless deserts coexist with humid, teeming jungles. This incredible diversity of landscapes would have created unique ecosystems where heroes could have come face to face with creatures long since erased from the pages of history. What incredible opportunities for exploration and perilous adventures! The very idea of a single continent gives rise to intriguing stories of unity and interconnectedness. When all peoples shared a single land, it could give rise to both great alliances and bloody conflicts. Imagine the ancient civilizations that rose and fell on this vast land. Their struggle for survival, their cultural exchanges, their wars and alliances, all of this could have formed the basis for epic sagas. The shared landscape would have dictated survival strategies, shaped belief systems, and defined relationships between tribes. Moreover, the breakup of Pangea itself carries enormous dramatic potential. Imagine a narrative built around this global cataclysm. Inexorable geological forces begin to tear the continent apart. This rift could serve as a metaphor for great change, loss, and transformation. The heroes of such stories would have to overcome not only physical obstacles, yawning chasms and new seas, but also emotional upheavals. Plot lines could show how entire peoples respond to these challenges, what drives them to survive and invent new ways of living. Finally, the dramatic climate shifts of the era could add another layer of tension. Extreme weather events, supervolcanic eruptions, and rapidly changing landscapes could all heighten the tension and raise the stakes to the limit. Such conditions would force the characters to confront their inner demons and external threats. As they learn to survive in this unpredictable wild world, we see how nature and the human spirit intertwine. Pangea opens the door to a world where compelling and thought-provoking stories about our ancient homeland can be crafted. Let's imagine one such story. Before us lies a primeval world where unprecedented ecosystems flourish and the most extraordinary creatures dwell. We see a small community of the first mammals, tiny and timid, desperately struggling to survive in the shadow of giant ferns and colossal conifers. Looming above them are the titans of the era, the dinosaurs, whose shadows blanket the earth. And then a group of courageous explorers, perhaps a tribe of the first hominids, sets off on a perilous journey into the very heart of Pangea in search of new lands and resources. As they traverse this vast, unified continent, they encounter incredible challenges and awe-inspiring sights. Imagine coming face to face with colossal reptiles, whose very presence evokes indescribable awe. These encounters are the perfect setting for a story about survival, human ingenuity, and our primal connection with the wild. And then great drama bursts into this story. Tectonic plates shift. The earth begins to tremble, splitting apart. Our heroes experience not only the physical, but also the profound emotional upheaval that such change brings. Families are separated by insurmountable fault lines. Entire tribes are forced to migrate in search of a new home. And then there are the volcanoes. The powerful volcanic activity of that era could have become the backdrop for stories of courage and despair. Imagine an eruption threatening to destroy an entire community. This gives rise to tales of heroes leading their people to salvation through chaos and fire. These stories can be tales of struggle against a changing environment or the daily struggle for survival. The scenarios unfolding across Pangea demonstrate the incredible resilience of life and the profound interconnectedness of all living things. They lay the foundation for our understanding of what it means to survive in an ever-changing world. The world of Pangea, an ancient supercontinent, offers us an endless canvas for stories full of drama and pristine splendor. Let's travel back 300 million years to an era when the face of our planet was completely different. At this time, Earth witnessed one of the most monumental events in its geological history. Disparate land masses that had drifted across the world's oceans for millions of years began to inexorably converge like pieces of a gigantic puzzle. This titanic movement of tectonic plates gave birth to a colossal supercontinent. Its name is Pangea. It was a single gigantic continent, washed by the waters of the planet's only ocean, which future scientists would call Pangea. For most of the late Paleozoic and the early Mesozoic era of the dinosaurs, this gigantic landmass remained virtually monolithic. Pangea reached its maximum size around 200 million years ago during the Triassic period. Modern scientists believe that the very configuration of this supercontinent profoundly influenced the entire planet's climate, governed ocean currents, and dictated the distribution of life. Imagine vast inland territories located thousands of kilometers from the ocean's moderating influence. They became arenas of extreme weather conditions, pushing living organisms to actively evolve and adapt. However, even continents are not bound by eternity. The era of Pangea proved short-lived by geological standards. Approximately 180 million years ago, during the Jurassic period, powerful forces once again began to churn beneath the Earth's surface. The movement of tectonic plates triggered a process of disintegration. The once united and powerful supercontinent began to crack at the seams and slowly fragment into separate parts. The very landmasses we know today as Africa, South America, and North America. The legacy of Pangea is more than just a fascinating chapter in a geology textbook. It is the key to understanding the great continental drift and the mechanics of tectonic plates. Today's science continues to study the ancient events that shaped our planet and finds echoes of them in modern landscapes and ecosystems. By delving into the history of Pangea, we begin to better understand the dynamic and powerful processes that continue to shape the world around us today. Around 300 million years ago, the birth of Pangea radically reshaped the entire geological map of the Earth. Until then, the continents were scattered across the planet, creating a much more fragmented worldview. Their unification into a single supercontinent not only altered the balance of land and water, but also caused global climate shifts, redirected ocean currents, and set a new vector for the evolution of life. As Pangea formed, the collision of tectonic plates triggered unprecedented geological activity. The Earth's crust was folded like a giant sheet of metal. This massive drift gave rise to entire mountain ranges on the planet, such as the Appalachians and the Urals, enduring monuments to the incredible power at work within the Earth's depths. In that distant era, at the turn of the late Paleozoic and early Mesozoic eras, the supercontinent Pangea dominated the Earth. But its days were numbered. Deep beneath the surface, geological processes were already gathering momentum that would tear this single landmass apart. Pangea itself was born from the collision and merger of ancient continents, but the same forces that created it were preparing to destroy it. About 175 million years ago, this tectonic mechanism was set in motion, and the Great Rift began. The key driver of this process was the movement of tectonic plates. Imagine the Earth's crust, the lithosphere, as a gigantic mosaic split into several enormous rigid plates. Beneath them lies a semi-liquid layer, the asthenosphere. Heat rising from the planet's molten interior creates powerful convection currents in this layer, like a boiling cauldron. These currents push and pull the plates in different directions. As this movement gained momentum, cracks appeared in Pangea's monolithic shell, harbingers of its impending breakup. As Pangea began to crack at the seams, future ocean basins began to form between the diverging land masses. In the giant rift we know today as the Atlantic Ocean, magma rose from the depths, solidifying and forming new oceanic crust. This gave rise to the Mid-Atlantic Ridge, a colossal underwater mountain chain. This process, fueled by continuous volcanic activity, is known as seafloor spreading. Furthermore, the merging of continents led to the formation of vast inland seas and completely reshaped coastlines. These changes created unique ecological zones that became the cradle for countless new species of plants and animals. But, as we already know, nothing lasts forever. About 200 million years ago, Pangea began its Great Rift, which ultimately led to the formation of our modern world. The continents breaking away from each other destroyed old ecosystems and created new ones, defining today's geography. A process geologists call rifting allowed hot magma to rise from the depths and create entirely new ocean basins, further altering the planet's map. The movement of tectonic plates constantly reshaped coastlines and triggered powerful volcanic and seismic activity, which shaped our modern geography. Even today, traces of Pangea are still visible on the Earth's surface. We can observe them in the distribution of mountain ranges on different continents, in the patterns of earthquakes, and even in the distribution of fossils of ancient flora and fauna. Research conducted by paleontologists on various continents only underscores the enormous influence of this ancient supercontinent on our understanding of geological history. Studying the birth and demise of Pangea not only reveals the secrets of the distant past, but also helps us better understand the dynamic forces that continue to shape our world today. This supercontinent, which dominated the late Paleozoic and early Mesozoic eras, marked a turning point in Earth's history. Its history, woven into the complex fabric of plate tectonics, is an integral part of our past. This monumental process involves several key players: giant tectonic plates, the North American, South American, Eurasian, African, Indian, Australian, and Antarctic. Each of these plates shifted slowly but surely over millions of years, colliding with its neighbors. Approximately 300 million years ago, these plates began their complex and inexorable dance of convergence, driven by colossal forces churning beneath the Earth's crust. The North American plate was sliding south, and the Eurasian plate was moving in the same direction. At the same time, the African plate, juxtaposed with the South American plate, began its intimate interaction with it. These slow but powerful movements resulted in the formation of the gigantic landmass we know as Pangea. This process radically altered the planet's geography and climate, making it even more significant. The formation of Pangea was inextricably linked to subduction zones, places where one tectonic plate literally dived beneath another. This process not only lifted mountain ranges like the Appalachians and the Urals into the sky, but also led to violent volcanic activity that painted prehistoric landscapes with fire and ash. The Earth's crust began to fold and buckle, creating the spectacular geological features we continue to study today. But the once united Pangea began to disintegrate under the same relentless tectonic activity. This great separation led to the formation of the continents we know today, and forever changed the course of life on Earth. Understanding the complex interactions between these tectonic systems underpins our understanding of biological evolution. Every fossil, every geological fault not only reveals the history of Pangea, but also highlights the ever-changing nature of our planet. Imagine that more than 300 million years ago, our world looked completely unrecognizable. Instead of the familiar picture of separate continents, all land was gathered into a single, enormous supercontinent, Pangea. It stretched from the North Pole to the South Pole, uniting lands that today are separate corners of our planet. This colossal landmass not only changed geography, but also had an incredible impact on the climate and all ecosystems. During the time of Pangea, the coastline's contours were completely different. Instead of the jagged continents we see today, there was a single landmass, and its coastlines, though extensive, looked different. When Pangea broke apart, its once broad coastlines, adorned with majestic cliffs and juxtaposed with arid deserts and swampy marshes near tropical regions, took on their current appearance. These new coastlines became more complex and jagged, forming countless bays and peninsulas. The climate along the coasts of Pangea was very different from what we know today. Much of the coastal land was sheltered in a temperate and humid climate teeming with dense forests and vibrant life, boasting a stunning diversity of flora and fauna. But the farther one traveled from the ocean's influence inland, the harsher the world became. The central regions of Pangea were extremely arid, forming vast deserts that contrasted sharply with the lush greenery of the coastal zones. This diversity created unique conditions for evolution, pushing millions of species to seek new ways of surviving as the continents drifted apart over millions of years. The process of coastal reshaping continued, shaping today's complex geography. The Atlantic Ocean slowly opened up like a giant curtain, not only altering the coastlines, but also creating conditions for the emergence of entirely new ecosystems. This dynamic history of our planet, marked by constant change, underscores the importance of studying the geological processes that created the world we live in. Around 300 million years ago, the supercontinent Pangea existed on Earth, connecting almost all of the planet's landmasses like pieces of a gigantic mosaic. It was at this time that crucial geological features began to form, many of which still influence our world today. Among the most striking creations of that era are the Appalachian Mountains in North America. They were formed by the enormous pressure generated by the collision of tectonic plates. The formation of Pangea caused such tension in the Earth's crust that it literally forced these ancient mountains to the surface. Their origins date back to deep prehistory. The Caledonian Mountains in Scotland and Scandinavia were formed under similar conditions. All of them are silent witnesses to a time when our planet was geologically active, sculpting its surface under titanic forces. Pangea also created vast deserts. The interior of the supercontinent, cut off from the moist ocean winds, became an arid, lifeless zone. This created gigantic desert landscapes similar to today's Sahara. At the same time, vast coal deposits formed in the marshy coastal regions, testifying to the incredibly lush vegetation of that era. The cycles of growth and decay in these rich ecosystems contributed to the accumulation of vast reserves of organic matter, which eventually turned into the fossil fuels we rely on even today. As Pangea began to break apart, approximately 150 million years ago, the remnants of these ancient geological processes continued to transform the landscape. The movement of new continents led to the emergence of the majestic mountain ranges we know today: the Rocky Mountains, the Andes, and the Himalayas. This is a narrative not only about geology, but also about deeply human experiences: loss, nostalgia for a lost unity, and the tentative hope of a future reunion. Using the image of Pangea, storytellers can convey this poignant sense of loss and hope, creating poignant stories about our own world and the challenges we face. Of course, Pangea is, first and foremost, a grand stage for recreating ancient life. Artists and screenwriters delve into the prehistoric past, bringing to life on screen the incredible diversity of creatures that once ruled this planet. From giant dinosaurs whose footsteps shook the earth to lush, alien-looking vegetation. This exploration not only expands our knowledge of biodiversity, it evokes a primal awe at the powerful forces of evolution that sculpted life in its myriad forms. Through their art, creators compel us to reflect on the unbreakable chain linking the distant past to the present, demonstrating how echoes of the world of Pangea still resonate in our contemporary reality. Pangea's appeal to storytellers stems from its ability to evoke both awe and pure wonder. These reflections inspire stories that weave ancient realities with modern ideas, allowing us to gain a deeper understanding of our own planet's history. By exploring these themes, we not only admire the beauty of ancient Earth, but also reflect on our own legacy. Imagine a science fiction story set precisely during that time, during the time of Pangea. It would be an incredible opportunity to delve into the very nature of human existence, exploring the eternal themes of survival and adaptability. The complexity of social structures against the backdrop of a world where all lands are connected into a single massif would create an incredible picture. Vast landscapes would stretch out before us, teeming with life, yet simultaneously concealing deadly threats at every turn. In such an imaginary reality, history could tell of the struggles and triumphs of ancient tribes, their attempts to find their place in this world, obeying its laws and their own instincts. The challenges people would face in such a unique ecosystem would reveal the deepest recesses of the human soul. Some communities might band together to hunt and defend, while others would wage merciless war over the resources the land provided. We would witness the formation of the first social bonds, how people learn to trust or betray one another. However, this process would inevitably lead to brutal conflicts. Abundance, or conversely, scarcity of resources would force our heroes to confront primal instincts, to hoard and protect their own, or to share with others. This story could depict the clash of completely different cultures moving across this vast continent. These encounters would generate tension, posing questions of identity, belonging, and the very essence of what it means to be human. Which path would they choose? Withdraw into isolation for the sake of perceived security, or embrace risky cooperation to become stronger together? These are precisely the questions such a story could answer. The relationships that form and collapse in this world would provide the basis for profound reflections on empathy, competition, and the eternal quest for unity in the face of shared adversity. A backdrop like Pangea would introduce the idea of constant change, both physical and social, to the narrative. Along with the slow but inexorable movement of tectonic plates, the characters themselves would change, evolving not only physically but also spiritually. Breathtaking landscapes would be more than just scenery. They would become full-fledged characters, influencing the destinies and decisions of people. In this world, people would create and reshape their humanity in the most unexpected and instructive ways. Through the prism of such a narrative, we would be able to more deeply understand how the distant past still influences our perception of the world today. Pangea, the supercontinent that existed approximately 300 million years ago, provides the perfect setting for exploring themes of survival and adaptation. Back then, Earth was a completely different place. Imagine gigantic land masses fused together with a single, boundless ocean lapping their shores. Living organisms encountered a reality we find difficult to even imagine today. This geography influenced not only the climate, but also the diversity of ecosystems, merging vastly different habitats into a single whole. Survival in such conditions was a colossal task. It required living creatures to adapt to a wide range of conditions, from the sun-baked deserts in the heart of the continent to the humid, swampy coastlines. This perennial theme of survival underscores the incredible resilience of life in an era of global geological and climatic upheaval. But then came the moment of great change. The supercontinent began to burst at the seams for countless species. This was both a true catastrophe and a tremendous challenge. Their familiar world literally shifted from under their feet, forcing them to adapt to entirely new, sometimes deadly, conditions. For example, they had to contend with abrupt climate changes and fluctuations in sea levels, something they had never experienced before. Species that had thrived for centuries in swampy lowlands could suddenly find themselves in the middle of an arid plain. This forced them to evolve, growing deeper roots to reach water or learning to survive with minimal moisture. On the other hand, new coastal zones or tropical forests could emerge in once arid regions, and life immediately rushed to exploit these new opportunities, developing unique mechanisms for thriving. This demonstrates the astonishing flexibility of life, its ability to respond to any challenge thrown at it by the environment. Million years after million years, the continents drifted apart. The Atlantic Ocean widened, and the once united land masses found themselves completely isolated. It was these immense geological forces, such as plate movement, that over millions of years creased, twisted, and shifted the future North America and Europe, shaping the landscape we know today. The Great Rift of Pangea didn't simply reshape the planet's geographic map. it had a colossal impact on the global climate and, most importantly, on the evolution of life across the globe. On the different continents, now separated by impassable oceans, completely unique ecosystems began to form. These ecosystems laid the foundation for the incredible biodiversity we see on Earth. The story of Pangea begins deep within our planet, where tectonic plates are in constant, relentless motion. About 300 million years ago, almost all land was gathered into a single fist, the supercontinent Pangea. But beneath this apparent stability lurked a living hell. Heat emanating from the Earth's molten core created gigantic convection currents in the mantle, which, in turn, set the tectonic plates in motion. Sooner or later, this movement would lead to catastrophic geological changes, including the inevitable breakup of Pangea. When tectonic plates collided or diverged, enormous stresses arose along their boundaries. These forces accumulated over millions of years, eventually destroying the continent from within. Moreover, adaptation gave rise to a ruthless evolutionary arms race that unfolded across the vastness of Pangea. Species fought incessantly for resources. Some developed highly specialized diets, while others refined their physical abilities for hunting or, conversely, to escape predators. This fierce competition resulted in incredible biodiversity, with every possible ecological niche filled as each organism adapted to its unique conditions. Thus, the story of Pangea is more than just a tale of survival. It is a grand saga of how life adapts and thrives in a constantly changing world. This transformation, in which life evolved in response to environmental challenges, continues to this day. We see Pangea's legacy everywhere, in common features, in species living today on different distant continents. The evolutionary paths that began on that single supercontinent still intrigue scientists. For millions of years, Pangea was not just a landmass, but a gigantic cradle of life. Its incredible will to survive and adaptability laid the foundation for the rich diversity we see today. The ancient supercontinent of Pangea is a fascinating place where fictional characters could learn life's deepest lessons. The lessons of adaptability and resilience learned from living in an era when the land itself and its climate were in constant flux, offer insights into how species can thrive by learning to embrace change. Faced with climate change, the emergence of new ecosystems, or the slow but inexorable breakup of the continents, the heroes of such a story would understand the value of flexibility and evolution, not only in a biological sense, but also in a philosophical one. Moreover, the very dynamics of Pangea's world would serve as a powerful impetus for personal growth. Characters enduring the most difficult trials and forced to unite for survival would understand that diversity is not a weakness, but a strength that helps them survive and succeed. Pangea serves as a constant reminder that change is inevitable. Watching their world slowly but surely change, splintering, the characters would realize that change is an integral part of life itself. This understanding could become the key to new horizons for them, to rethinking how to cope with loss and find the strength to start anew. Stories about periods of transition, whether personal dramas or global cataclysms, can be a powerful tool for reassessing one's own values. Finally, the spectacular landscapes of Pangea, with its sky-high mountains and endless deserts, embody the grandeur and pristine beauty of our planet. The heroes of such a story would learn the importance of respecting and preserving the environment that gives them life. Learning about geographical diversity and its impact on all life would instill in them a deep reverence for nature and an understanding of the need to protect its fragile ecosystems. Through these lessons, the heroes would become stronger, wiser, and more harmonious with the world around them. Even music, that most powerful instrument for conveying emotions, can transport us to that ancient era. Composers, inspired by the grandeur of Pangea, can create sonic canvases that conjure up images of a world that existed hundreds of millions of years ago. How can we peer into a world that disappeared hundreds of millions of years before the advent of humans? How can we see what none of us have ever seen? The answer sometimes comes not from scientists' laboratories, but from artists' workshops and composers' studios. It is creative imagination that allows us to touch the mysteries of the supercontinent Pangea, to understand its birth and epic disintegration. Imagine canvases that bring the landscapes of that ancient world to life. Impenetrable, humid jungles and colossal mountain ranges that once divided this single landmass. Now listen to music that attempts to convey the unimaginable rumble of shifting tectonic plates. These are symphonies that convey the grand drama of an entire world's rupture. Such works of art become a true time capsule, transporting the viewer to the distant past. Pangea was once home to millions of diverse ecosystems. Contemporary sculptures and installations can recreate the unique flora and fauna that flourished in its vast expanses. Intricate patterns on stone or metal can symbolize the ancient forests that covered the continent like a dense carpet, or recreate the unique animals that inhabited these lands, uniting them into a unified picture of the universe. The power of such images can pierce the depths of time and offer us a glimpse into that lost world. A visual narrative told through the language of art awakens our natural curiosity and inspires a deeper understanding of our planet's prehistoric environment. Scientific discoveries that detail the geological drama of Pangea today provide an inexhaustible source of inspiration for music. Composers can create entire symphonies that convey the emotional landscape of that ancient era. They can use the sounds of nature or compose melodies that mimic the Earth's movement. In these melodies, we can hear rhythmic shifts symbolizing the slow but inexorable drifting apart of the continents. These rhythms can reflect the birth of new oceans that filled giant cracks in the Earth's crust. The emotional response evoked by such music can shed light on complex geological processes and connect the listener to an era when the map of our planet looked completely different. By combining painting, sculpture, and music, we create an immersive, multi-sensory experience that makes the history of Pangea almost tangible. These expressive art forms have the power not only to educate, but also to inspire, transforming dry scientific concepts into profound and unforgettable experiences. The result is a compelling story that highlights the inextricable links between art, music, and the natural world throughout Earth's history. The very idea of Pangea, a gigantic supercontinent that existed hundreds of millions of years ago, offers a fascinating lens through which we can reimagine the ancient myths of diverse cultures. Remarkably, the myths of many peoples often explore the same themes: unity and subsequent division, creation and inevitable destruction. And here, the story of Pangea emerges as an ideal symbol of a time when all land on the planet was united. This could serve as the perfect backdrop for ancient legends, suggesting that our ancestors may have possessed a deep, intuitive understanding of the interconnectedness of all things long before the advent of modern geology. Imagine an ancient myth in which the earth was once a single, flourishing kingdom, filled with diverse life forms and peoples. However, as the story unfolds, cracks and fissures begin to appear in this land, eventually leading to the formation of separate continents separated by oceans. This physical division may be a metaphor for the emotional or social divisions we observe in human society. Using the image of Pangea, we can interpret ancient tales as parables about the unity and disunity of humanity. They show us that despite all our cultural and geographical differences, we are all connected by a common origin and perhaps a common destiny. This understanding is more important than ever in our modern fragmented world. Moreover, the story of Pangea can be directly linked to themes of climate change and environmental protection. Ancient myths often reflect the complex relationship between humans and nature. In this context, the story of Pangea's breakup can be perceived as a dire warning. After all, the continent split as a result of colossal geological activity, reminding us of the incredible power of nature and the consequences of global environmental disasters. These ancient stories, projected onto modern issues, force us to consider how our actions today can impact the future of the planet. Rethinking the story of Pangea through the lens of ancient myths fosters a deeper understanding of our shared history and collective responsibility. It reminds us that we are all connected by invisible threads of life, just as the continents were once connected. By creating a new narrative centered around Pangea, we have a unique opportunity to transform public understanding of geological history. This supercontinent, which existed more than 200 million years ago, is a fascinating chapter in the biography of the Earth, highlighting its original unity. The events of its formation and breakup, viewed from a new, more dramatic perspective, can reveal the dynamic processes that shaped our planet as it is today. In this narrative, Pangea emerges not simply as a stationary landmass on a map, but as a living, breathing, and thriving ecosystem where a wide variety of flora and fauna coexisted. This perspective allows us to better understand the complex relationships between species and the environment that existed in that distant era. By showing how geological events like continental drift directly influenced evolutionary paths, we can give viewers a clearer understanding of how the Earth's shifting plates shaped not only landscapes, but the very fabric of life. Furthermore, the modern history of Pangea can connect distant geological processes to the environmental challenges we face today, such as climate change and rapid habitat loss. The historical context of Pangea's formation and disintegration can serve as a reminder of Earth's incredible resilience, yet also its fragility. It's a reminder that while our planet is constantly changing, it is capable of recovering even from the most severe catastrophes. Such a renewed narrative could inspire a deeper understanding of geology within the context of human history, we can integrate the story of Pangea with cultural and scientific achievements to highlight how closely human civilization is tied to Earth's geological fate. This, in turn, fosters the formation of alliances or entire trading networks, which can significantly improve the quality of life. But such interactions can also lead to the emergence of complex societies, where social status and political power become the primary motivations for those seeking to improve their situation. Finally, spiritual or philosophical questions can have a profound impact on the motivations of these people. In a world full of natural wonders and dangers, characters may find meaning in their connection to the earth and its natural cycles, in a deep respect for nature. This can manifest itself in rituals, stories, or art, prompting them to seek a deeper understanding of themselves and their place in this vast, unified world. In a world like Pangea, motivations can range from the simple struggle for survival to lofty aspirations for knowledge, power, and spiritual meaning, creating a rich and varied tapestry of human experience. Let's travel back in time to a time when the map of our world looked completely different. The continents we know today were bound together, forming a single, colossal landmass. To peer into this abyss of time, geologists today employ a whole arsenal of sophisticated methods. Their goal is to reconstruct the appearance of that ancient world, at the center of which stood the supercontinent Pangea, which existed approximately 300 million years ago. How do scientists reconstruct a world that long ago disappeared? One key approach is the meticulous analysis of rocks and fossils, which today are scattered across the planet. Imagine a giant jigsaw puzzle. By studying the composition of rocks and how they are laid down, researchers are assembling its disparate pieces. They can trace the enormous movements of tectonic plates, the same colossal forces that first assembled Pangea and then, millions of years later, tore it apart. Determining the precise timing of this geological rupture is of paramount importance here. To do this, scientists use radiometric dating. Simply put, they are able to measure the age of ancient rocks, allowing them to construct a precise chronology of events, when exactly certain geological structures formed. This process has created a layered cake of geological deposits on the planet, and studying these stratigraphic layers allows paleontologists to compare strata from completely different regions. This clearly demonstrates how widely separated land masses were once inextricably linked. These methods repeatedly lead scientists to astonishing discoveries. They find striking similarities in geological samples across different continents. This only strengthens their conviction that all these lands were once a single entity. But the most compelling evidence is preserved in stone, fossil remains.